ሰላም ለእናንተ ይሁን። ዛሬ በዚህ ቪዲዮ ይዤላችሁ የቀረብኩት ወርክሺት 2 ማለትም ለቤዚክ ማትማቲክስ ፎር ሶሻል ሳይንስ ፋንክሽን ላይ ያሉ ጥያቄዎች የተካተቱበት ወርክሺት ሶሉሽን ይሆናል ማለት ነው። ስለዚህ እንደተለመደው በቀጥታ ወደ ጥያቄዎቹ ከመሄዳችን በፊት ምናልባት ለዚህ ቻናል አዲስ የሆናችሁ ልጆች አሁንም ሰብስክራይብ እና ይህንን ቪዲዮ ደግሞ ላይክ በማድረግ እንድትጀምሩ አበረታታለሁ። ጥያቄዎቹ ወርክሺቱ ይህን ይመስላል። ስለዚህ በርካታ ጥያቄዎች ናቸው። በአንድ ቪዲዮ የሚጠቃለሉ አይደሉም። ቢቻልም እንኳን ብዙ ሰዓት የሚወስድ ስለሚሆን በሁለት ፓርት መስራት ነው የፈለኩት። ስለዚህ ይህ ቪዲዮ የመጀመሪያው ፓርት ይሆናል ማለት ነው። ይህን ካልኩ በኋላ በቀጥታ ወደ ጥያቄዎቹ በምንሄድበት ጊዜ የመጀመሪያው ጥያቄ ኦን ኢኒኳሊቲ ላይ ይሆናል። ኢት ሴይዝ ሶልቭ ዘ ሊኒየር ኢኒኳሊቲ 3x minus 7 less than 2. Therefore, in order to solve such a linear inequality, we have to apply the usual methods that just simple simplification. So that, for example, if we add 7 to both sides of this inequality by using that of addition property, we have this one that is 3x less than 9. And if we divide both sides of this inequality by 3, we have this one that is x less than 3, because dividing both sides of the given inequality by a positive real number will not affect the inequality, and the sign of inequality must be kept as it is. And therefore, the solution set will be x less than 3 or 3 to that of negative infinity. Next question. Solve the linear inequality again, 5x plus 4 greater than or equal to 19. Again, in order to solve this inequality, using addition and product or simply quotient property. If we subtract 4 from both sides of this inequality, we have 5x plus 4 minus 4 is 5x, and 19 minus 4 is 15, so that we have 5x greater than or equal to 15. And if we divide both sides of this inequality by the coefficient of the variable that is x, just to make x alone, that means we have x greater than or equal to 3. Therefore, the solution set will be x greater than or equal to 3, or the closed interval that is including 3 from 3 to positive infinity. Next question. Again, it is on inequality 2 minus x over 3 greater than 5. Similarly, if we, for example, that is subtract 2 from both sides of this inequality, we have minus x over 3 greater than 3. And in order to make x alone here, let us multiply both sides of this inequality by the coefficient of the variable x, which is negative 1 over 3. Therefore, but multiplying both sides of this inequality by negative 3 will not, or simply must change the sign of inequality from greater than to less than sign, so that when we multiply both sides of this inequality by negative 3, we have x less than negative 9. Therefore, the solution set will be x less than 9, or an open interval from negative 9 to negative infinity. Next, 7x minus 2 less than or equal to 3x plus 10. Therefore, again, in order to solve this one, we have to collect the variables to the left side of the inequality and the real number to the right side, so that we can subtract, for example, that simple 3x to both sides of this inequality, just to bring this one to the left side, and we have to add to the both sides of this one, just to take minus to the right side. Therefore, we have, that is, if 3x is subtracted from both sides of this inequality, we have 7x minus 3x is 4x, and 3x minus 3x is 0, so that 4x minus 2 less than or equal to 10 will be obtained, or simply, there is an inequality which is obtained from this one by subtracting 3x from both sides. Then when we take again minus 2, or simply if we add 2 to both sides, we have 4x less than or equal to 12. And if we divide both sides by 4, we have x less than or equal to 3, so that the solution set for this inequality will be set of real number less than or equal to 3, or closed interval that is from positive 3 to negative infinity. So that this interval will be the solution set for this inequality. Next, it is an absolute value. Solve the linear inequality, that is the absolute value of 2x minus 5 less than 7. Therefore, the solution set could be, using the absolute property, we know that the absolute value of 2x minus 7 less than 7 means, that is the absolute value of 2x minus 5 less than 7 means, this one, that is 2x minus 5, must be in between negative 7 and positive 7. So that we have two inequalities, sign of inequalities here, and three terms are connected by using these two inequalities. Therefore, in order to find the value of the possible values of this one, that's a variable that is x, that can make this inequality to be true. If we add 5 throughout, that is simply with minus 7 to x minus 5, and this one, that's simply 7. That is just to make x alone here. We have minus 7 plus 5 is minus 2, 2x minus 5 plus 5 is 2x, and 7 plus 5 is 12. ስለዚህ እናገኘን እንደገና x ብቻውን እንዲቀርልን ሌታስ divide minus 2 2x and 12 by the coefficient of the variable x, which is 2. And therefore, when we do this, we have this one, that is minus 1 less than x less than 6. Therefore, the solution set could be the set of real number in between minus 1 and 6, or it is an open interval from minus 1 to positive 6. Therefore, this interval will be the solution set for this inequality, which is the absolute value of 2x minus 5 less than 7. Next, solve each of the following quadratic inequalities and represent the solution set on a real line. We have this one, that is the first one, x squared minus 5x plus 6 plus greater than 7, I mean 0. Next, 2x squared plus 4x minus 2 less than or equal to 0. C, x squared plus 4x plus 4 greater than or equal to 0. And lastly, we have minus x squared plus 6x minus 8 less than 0. So let us start from the first one. What we are given here is x squared minus 5x plus 6 greater than 0 is given, so that we are asked just to find the solution set of this quadratic inequality. ስለዚህ በቅድሙ የሚለየው ምንድነው? ቅድም ያየናቸው ምንድናቸው? they were linear inequalities። እዚህ ደግሞ ኳድራቲክ ወይም ደግሞ ዲግሪው ሁለት የሆነ ኳድራቲክ ኢኒኳሊቲ የተሰጠን ማለት ነው። ስለዚህ ይህንን ሶልቭ በምናደርግበት ጊዜ ለምሳሌ ፋክቶራይዜሽን ሜተድ ልንጠቀም እንችላለን፣ ሳይድ ቻርት ሜተድ መጠቀም እንችላለን። ለምሳሌ factorization method, if we factorize this one, that is, we need to find two real numbers whose sum is negative 5 and whose product is positive 6. And these two real numbers are minus 2 and minus 3, so that this one, that is x squared minus 5x plus 6, can be expressed as the product of x minus 2 and x minus 3. So that is fully the factorized form of this quadratic term. Therefore, it must be greater. አሁን እዚህ ጋር ይሄንን በዚህ መልኩ ፋክተራይዝ ካደረግን በኋላ የነዚህ ሁለት ሊኒየር ፋክተሮች ፕሮዳክት ፖዚቲቭ ሊሆን የሚችለው መቼ ነው ብለን ስናስብ ሁለት ኬዞች አሉን። የመጀመሪያው ሁለቱም ሊኒየር ፋክተሮች ፖዚቲቭ በሚሆኑበት ኢንተርቫል ላይ ወይም ደግሞ ሁለቱም ፖዚቲቭ ናቸው ብለን ስናስብ ነው። ሁለተኛው ደግሞ ሁለቱም x minus 2 እና x minus 3 እነዚህ ሁለት ሊኒየር ፋክተሮች በተመሳሳይ ጊዜ ኔጌቲቭ በሚሆኑበት ጊዜ ነው። ስለዚህ የዚህ ሶሉሽን ሴት ምን ይሆናል ማለት ነው? በሁለቱም ኬዝ የምናገኛቸው ሴት ኦፍ ሪል ነምበርስ ዩኒየን ይሆናል ማለት ነው። ስለዚህ the product is positive when both factors have the same sign. That is either the first case, that simply both x minus 2 and x minus 3 positive በሚሆኑበት ጊዜ ነው። ስለዚህ እነዚህ ፖዚቲቭ የሚሆኑት መቼ ነው? when x is greater than 0 and x is greater than ግሬተር ዛን 3 ስለዚህ የነዚህ ኤንድ ነው። ሁለቱም በተመሳሳይ ጊዜ ነው መሟላት ያለባቸው። ስለዚህ የነዚህ ሁለቱ ኢንተርቫሎች ኢንተርሴክሽን ማለት that is the intersection of x greater than 2 and x greater than 3 will be x greater than 3, so that x greater than 3 could be half of the solution set for this quadratic inequality. The other possibility where the product of these two linears to be positive is that both x minus 2 and x minus 3 needs to be negative. That means x minus 2 less than 0 and x minus 3 less than 0. ስለዚህ እነዚህ ሁለት ሊኒየር ፋክተሮች ኔጌቲቭ የሚሆኑት x minus 2 ኔጌቲቭ የሚሆነው when x is negative 2, I mean x is less than 2, and x minus 3 will becomes negative when x is less than 3. ስለዚህ end ነው ይሄ ኢንተርሴክሽን ነው. So that the intersection of these two intervals will be the smallest intervals, that is x minus 2. ስለዚህ የዚህ ሊኒየር ኳድራቲክ ኢኒኳሊቲ ሶሉሽን ማለት በእነዚህ ሁለት ኬዞች ላይ የተገኘ ሶሉሽን ዩኒየን ይሆናል ማለት። ምክንያቱም እነዚህ የተያያዙበት ይሄ ኦር ነው። ኦር ስታንድስ ፎር ዩኒየን ዴርፎር the union of x less than 2 union x greater than 3 could be the solution set for this inequality. Therefore the solution set is this one. ስለዚህ within this interval if you take any real number so that this quadratic inequality will be satisfied. B 2x square plus 3x minus 2 less than or equal to 0 is given. Therefore, in order to solve this quadratic inequality, again using data factorization, hopefully this quadratic term can be expressed as or simply as the product of these two linear factors. And the product of these two linear factors, ቅድም የተጠቀምነውን ኳድራቲክ ወይም ደግሞ ፋክቶራይዜሽንም ደግሞ ፕሮፐርቲውን አፕላይ ማድረግ እንችላለን፣ ወይም ደግሞ ምን ማድረግ እንችላለን? ይሄ ሳይን ቻርት ሜተድ መጠቀም እንችላለን። ስለዚህ ሳይን ቻርት ሜተድ ለመጠቀም መጀመሪያ we need to find the critical points. Critical points means they are points or simply the values of the variable that can make the quadratic equation to be zero. The zero of the quadratic equation, that means the equation which is obtained from the inequality by substituting or replacing the sign of inequality by simply equality. ስለዚህ ይሄን ወደ ኢኩዌሽን ከቀየርን በኋላ የኳድራቲክ ኢኩዌሽኑ ዜሮዎች ማለት የዚህ የኢኒኳሊቲ ክሪቲካል ፖይንቶች መሆናል ናቸው ማለት ነው። ሌላው እነዚህ ሁለት ክሪቲካል ፖይንቶች ምንድነው የሚያደርጉት? ሁለት ክሪቲካል ፖይንቶችን ዲስቲንክት ካገኘው ለምሳሌ አንዱ ሴት ኦፍ ሪል ነምበር ወይም ደግሞ ሴት ኦፍ ሪል ነምበር ወይም ደግሞ ሪል ላይኑ ለሶስት ነን ኦቨርላፒንግ ኢንተርቫሎች ይከፈላል። ስለዚህ የዚህ ኳድራቲክ ኢኒኳሊቲ ሶሉሽን ሴት ማለት እዚህ በእነዚህ ክሪቲካል ፖይንቶች በተከፈሉ ሶስት ነን ኦቨርላፒንግ ኢንተርቫሎች ወይ ሁለቱ ሊሆኑ ይችላሉ ወይ አንዱ ብቻ ሊሆን ይችላል። ስለዚህ እሱን እንዴት ነው የምንለየው? ወይም ደግሞ እሱን ለመለየት we can apply or simply use the application of sign chart method. ስለዚህ የመጀመሪያው ኢንተርቫል that is x is equal to መጀመሪያው critical point that simply -2 from -2 that of negative infinity. The second one is from negative in between -2 and positive 1 over 2, and the last one, the third one is said to be from 1 over 2 to that positive infinity. ስለዚህ እነዚህ ሶስቱም ነን ኦቨርላፒንግ ኢንተርቫሎች ናቸው። ስለሆነም የዚህ ኳድራቲክ ኢኒኳሊቲ ማለት ከእነዚህ ሶስት ኢንተርቫሎች ወይ የመጀመሪያው ሊሆን ይችላል፣ ሁለተኛው ሊሆን ይችላል፣ ሶስተኛው ሊሆን ይችላል። ከእነዚህ ከሶስቱ የትኞቹም ሁለት ሊሆን ይችላል ማለት ነው። ስለዚህ እንዴት ነው ምንድነው የምናደርገው? የመጀመሪያው ለምሳሌ የመጀመሪያው ሊኒየር ፋክተር የዚህ ኳድራቲክ ኢኒኳሊቲ ኤክስ ፕላስ 2 ነው። ስለዚህ ይሄ ኤክስ ፕላስ 2 በእነዚህ በሶስቱ ኢንተርቫሎች ላይ ያለው ሳይን ምን ይመስላል የሚለውን እንወስዳለን። ለምሳሌ from negative to negative infinity x plus 2 is negative. ለምሳሌ just as a testing point or simply checking point, -3 is within this interval. If we substitute -3 for x here, it is negative, so that x plus 2 is always negative within this interval. And we in between -2 and that of positive 1 over 2, that means if we take the value for x which is greater than -2 and less than positive, ለምሳሌ 0 በምንወስድበት ጊዜ If you substitute 0 here, x plus 2 will becomes positive. Similarly, the same term, the factor that simply x plus 2 within this interval that is 1 over 2 to positive infinity is positive. Similarly, the second linear factor that is 2x minus 1 could be within the first interval is negative, positive. ከዛ በኋላ እነዚህ ሁለት ሊኒየር ፋክተሮች ኔጌቲቭ ሆኑ ማለት ስለዚህ እነዚህ ይሄ ምንድነው የሚሆነው የዚህ ፕሮዳክት ማለት ኔጌቲቭ ወይም ደግሞ ዜሮ የሚሆንበት ኢንተርቫል ላይ የተፈለገው ስለዚህ የነዚህ ሁለት ሊኒየር ፋክተሮች ፕሮዳክት ይሄንን ኳድራቲክ ኢኒኳሊቲ ይሰጠናል ስለዚህ የዚህ ኳድራቲክ ኢኒኳሊቲ ሳይን ምን ይሆናል ሲባል የነዚህ ሁለት ሊኒየር ፋክተሮች ሳይን ፕሮዳክት ይሰጠናል ማለት ነው እዚህ ጋር within minus negative infinity ሁለቱም ኔጌቲቭ ናቸው so that negative times negative will be positive similarly within the interval from minus to positive 1 over 2 both the first x plus 2 is negative positive but 2x minus 1 is negative so that positive times negative ይሄ ፕሮዳክት ኔጌቲቭ ይሆናል ማለት ነው ሌላ እዚህ the last one from 1 over 2 to positive infinity ሁለቱም ፖዚቲቭ ናቸው so that positive times positive is positive አሁን ይሄንን ሳይን ቻርቱን በዚህ መልኩ ካዘጋጀን በኋላ የሚቀጥለው ስራችን ምንድነው የሚሆነው ወደ ኦሪጂናል ኢኒኳሊቲያችን እንመለሳለን ኢኒኳሊቲያችን ምንድነው የሚሆነው የሚለው ፖዚቲቭ የሚሆንበትን ነው ወይስ ኔጌቲቭ ወይም ደግሞ ኔጌቲቭ እና ዜሮ የሚሆንበትን ነው ወይስ የትኛውን ነው የተጠየቅነው የሚለው እናያለን ስለዚህ ጋር ይሄ ኳድራቲክ ተርም ኤክስፕሬሽን ኔጌቲቭ ወይም ደግሞ ዜሮ የሚሆንበት ኢንተርቫል ላይ የተጠየቅ ነው ስለዚህ ለምሳሌ እዚህ ጋር x minus 2 በሚሆንበት ጊዜ exactly minus ሲሆን እዚህ ጋር 0 ይሆናል ይሄኛው ፖዚቲቭ ኔጌቲቭ ነው እዚህ ጋር x 0 x ኔጌቲቭ 1 over 2 ሲሆን 0 ይሆናል እዚህ ጋር 1 over 2 ሲሆን 0 ይሆናል ስለዚህ ኔጌቲቭ ይሄ ኢንተርቫል ወይም ደግሞ ይሄ ማለት ኔጌቲቭ የሚሆንበት ሳይን ቻርት ወይም ደግሞ from this chart ይሄ ኢንተርቫል from negative 1 over 2 to positive 1 over 2 ነው ማለት ነው ስለዚህ negative 1 over 2 እና positive 1 over 2 ኔጌቲቭ የሚሆንበት ነው ነገር ግን ምንም ይጠቃለላል ዜሮ የሚሆንበትም ይጠቃለላል ስለዚህ -2 x plus 2 0 ስለሚያደርግ 0 times this one will become 0 1 over 2 2x minus 1 0 ስለሚያደርግ ይሄ x plus 2 ከ0 የተለየም እንኳን ቢሆን ይሄ 0 ከሆነ 0 times an expression is 0 so that 0 less than or equal to 0 it becomes 0 so will be satisfied ስለዚህ the solution set could be a closed interval from negative 2 to positive 1 over 2 ይሆናል ማለት ነው therefore they hit the solution set question number C x squared plus 4x plus 4 greater than or equal to 0 is given. Therefore, the solution set of this quadratic inequality will be, I think it is perfect trinomial. This one is perfect trinomial, which is x squared plus 4x plus 4. So when the factorized form of this expression could be x plus 2, the whole square, which is greater than or equal to 0. ስለዚህ ብዙ justification አያስፈልገውም. The square of every real number is positive or simply it becomes 0 whenever x is exactly equal with that of -2 and therefore 0 since a square is always non-negative so that it is either positive or simply 0 so that the solution set of this inequality will be a set of real numbers so that any real number can satisfy this quadratic inequality. D minus x squared plus 6x minus 8 is negative. Therefore, again, if we multiply this point by -1, just to make the leading coefficient of this to be positive, so that we have the inequality that is x squared minus 6x plus 8 greater than 0. It was less than because if a given inequality is multiplied or divided by a negative number, the sign of inequality must be reversed or simply changed. And then The factorized form of this inequality could be x minus 2 and x minus 4, so that this product will become positive if either both these two linear factors are positive or negatives. ስለዚህ ይህ ፕሮፐርቲን አፕላይ በምናደርግበት ጊዜ the solution set could be x less than 2 union, that means simply or stands for union x greater than 4. Therefore ከዚህ ኢንተርቫል ወይም ደግሞ ከዚህ ማንኛውንም ሪል ነምበር ወስደን ለኤክስ ሰብስቲት ብናደርግ this inequality will be satisfied. Okay, I think already in its factorized form. Therefore, this could be positive. Again, or simply the critical points are x equal to 1 and x equal to negative 2. That is the zero of the linear factors of the given polynomial, quadratic inequality. And therefore, the product is positive outside the interval. Outside the interval means when x less than minus 2 or x greater than positive 1. X greater than positive 1. We can apply the property that already we applied just around the first quadratic inequality. Okay, question number 3. Consider sets A and B with their corresponding elements. Then after we are given this to set it, the question that follows from this one could be, we are asked just to list all the elements in A cross B, list all relations R from A to B, and lastly list all functions F from A to B. So let us see the first one. We know that the cross product of any two sets A cross B could be, it is the set containing in the form of that of A over B, where the first entry selected from the elements of the first set and the second entry for each element or simple order pair must be selected from the elements of the second set, that is set B in this case. Okay, ስለዚህ A እና B ምንድን ነው ያላቸው? ወይም ደግሞ the elements of A are 1 and 2 and the elements of B are S and T, so that one can be combined with both the elements of B, that is S and T, so that we can have 1S, 1T, and 2S and 2T. Therefore, we have 1S, 1T, 2S, and 2T could be the cross product of the two sets, that is A and B. And ሌላው እዚህ ጋር ማስታወስ የሚገባን ነገር ምንድን ነው? number of elements of A cross B ከnumber of elements of A and B ጋር ሪሌሽን አለው። ስለዚህ ያ ማለት A እና B ሁለቱ ፋናይት ሴት ከሆኑ that means if they do have fixed number of elements, ስለዚህ የA cross B number of elemenቶች number of element of A times number of elements of B ነው። ስለዚህ እዚህ ሁለት አለ፣ ይሄም ሁለት አለ። ስለዚህ the number of elements of A cross B must be 2 times 2, that is 4, so that we have 4 elements here. Similarly, a relation is any subset of A cross B. That means the second or simply the question could be, we are asked just to list all relations are from A to B. relation form እንድናደርግ ወይም ደግሞ ይሄ ሊስት እንድናደርግ ነው። ስለዚህ a relation is any subset of cross product of these two sets, or simply cross product already እዚህ ጋር ተሰጥቶናል። ስለዚህ ለዚህ subset የሆነ any set it can be considered as a relation R from A into B. ለምሳሌ we know that empty set is the subset of any set. ስለዚህ አንዱ ማን ሊሆን ይችላል? empty set ሊሆን ይችላል። ይችን ኤሌመንት ብቻ the relation containing only 1 and S or 1 and T, 2 and S, either of this one or the combination of 2 or the combination of 3 or the set itself, that is across B, could be the relation which is defined from A into B. ስለዚህ we can have this example that simply set empty sets. Since empty set is the subset of any set, the set containing only the first element, that is 1S, the set containing 1S and 2T, the set containing 1S, 1T and 2S, or the set containing 1T and 2S. ስለዚህ ብዙ ነው ማግኘት የምንችለው። ራሱ A cross B እዚህ ጋር ኢንክሉድ ይደረጋል። ስለዚህ በዚህ መልኩ ማግኘት እንችላለን ማለት ነው። with respect to that of the number of elements of this one, እንግዲህ ኤ ክሮስ ቢ ወይም ደግሞ ይሄ ሪሌሽን አር ፍሮም ኤን ቱ ቢ ማለት ለዚህ ለኤ ክሮስ ቢ ኤኒ ሳብሴት ከሆነ we know that the maximum or simply the number of subsets of any finite set could be to the power of the number of elements of the given set. We have the number of elements of A cross B is 4, so that to the power of 4 could be 16 relations can be constructed based on the given set is A and B. Next one, that is C. A function assigns exactly one element of B to each element of A. That means first C says list all functions f from A to B. Therefore, we have this one. Therefore, the functions are f1, for example. ስለዚህ አንድ function from A to B ከሆነ ምን ማለት ነው? የመጀመሪያው ዶሜኑ A መሆን አለበት. And the range of the given function must be the subset of its codomain, that is simply B. ስለዚህ ይሄ አንዱ function ነው, because each and every first entry is paired with exactly one element within its range. ስለዚህ የዚህ ዶሜን ለምሳሌ 1 and 2, which is exactly A, and second could be 1s and 2d. Again, the domain is the same, that's simply the set A itself. 1 and 2d and 2s, and lastly we have 1 and 2d. ከነዚህ ከአራት ውጭ ሌላ የለንም። ስለዚህ based on the elements of set A there, the possible function that can be constructed could be only these four functions. Okay, question number 4. Let A is equal to the set containing W, X, Y, and Z, and B is equal to 3, 4, 5. Then each of the following sets of is a relation from A to B. Determine which ones are functions. So what we are given here is this one, B, C, and D. ስለዚህ ከነዚህ ፋንክሽን የሆነ ነው የምናወጣው ወይም ደግሞ የምንመርጠው ማለት እነዚህ ሪሌሽኖች ናቸው በሙሉ, because all this one that simply are the subset of A cross B. ስለዚህ ከነዚህ ሪሌሽኖች ውስጥ ፋንክሽን ሊሆን የሚችለውን ማግኘት ወይም ደግሞ ሴሌክት ማድረግ ነው። ስለዚህ አንድ ሪሌሽን ፋንክሽን የሚሆነው መቼ ነው ስንባል ወይም ደግሞ ሲባል ምን ማለት ነው? የመጀመሪያው the function is defined from A to B already or simply without anything. The domain of the given function must be A. A መሆን አለበት ዶሜኑ ይሄ መሆን አለበት። ስለዚህ ለምሳሌ እዚህ ጋር w3 x4 y5 ይላል። ማን የለም አሁን እዚህ ጋር z የለም። ስለዚህ ይሄ ሪሌሽን ፋንክሽን ሊሆን አይችልም ማለት ነው። ፋንክሽን ነው፣ ነገር ግን ይሄ ፋንክሽን it is not a function from A to B because the domain is different from that of A. አርን በምንወስድበት ሁለተኛውን ቢንስ በምንወስድበት ጊዜ we have w3 x4 y5 z5 w x y z ዶሜኑ ይሄም እንኳን ቢሆን ነገር ግን ይሄ ፋንክሽን አይደለም፣ ምክንያቱም y is the image of this one, that's simply y. Sorry. Okay, they hit the function clearly. It is a function. That means the domain is the set containing w, x, y, and z, which is exactly A. So that each and every element of the domain is paired with exactly one element within its range. Therefore, B is a function. ይሄኛውን እዚህ ጋር ስንመጣ we have w3, x3, y3, z3, which is a constant function. W, x, y, z is the domain, so that is a constant function. Therefore, this relation is a function. And lastly, that's simply D, w3, x5, y4, z3, and z4. W, x, y, z, the domain is the same, that's simply A, but ይሄ ፋንክሽን አይደለም። ምክንያቱም one of the first, the last component of this one that simply that has two different images which are 3 and 4. ስለዚህ የፋንክሽን ፕሮፐርቲ አይደለም due to the existence of these two elements. Therefore, this is not a function. ስለዚህ ኤ እና ዲ ፋንክሽኖች አይደሉም፣ ቢ እና ሲ ግን ፋንክሽኖች ናቸው። if you need the justification, a relation is a function if every element of the domain has exactly one image. And therefore, A is not a function because Z has no image. ያ ማለት ዶሜኑ አልሆነም ማለት ነው። B function because each element of A has exactly one image. B is also a function because each element has exactly one image again. But D is not a function because Z has two images 3 and 4, which are different. Therefore, this is the solution. Okay, next. Determine if the following relations are functions, then state the domain and their range. ስለዚህ ሁለት ጥያቄ ነው የተጠየቅነው። መጀመሪያ የተሰጠን ሪሌሽን ፋንክሽን ነው ወይስ አይደለም የሚለውን ጀስቲፋይ እናደርጋለን። ከዛ ቀጥሎ ደግሞ የተሰጠንን ሪሌሽን ወይም ደግሞ ፋንክሽን ከሆነ ዶሜን እና ሬንጁን ስቴት እናደርጋለን ማለት ነው። ስለዚህ የመጀመሪያው ለምሳሌ ሴት ኤ 1 1 2 2 3 4 and 4 5 I think it is a function ምክንያቱም ሁሉም የመጀመሪያዎቹ ኤንትሪ ወይም ደግሞ ዶሜኑ ኤለመንት አንዳንድ ኢሜጅ ብቻ ነው ያላቸው። ስለዚህ ዶሜኑ ማን ይሆናል ሲባል the set containing all the first entries of each element so that 1 2 3 and 4 could be the elements of this function. ሁለተኛው ቢ 1 5 5 1 5 2 2 5 ይሄ ፋንክሽን አይደለም because of the existence of these two elements 5 1 and 5 2 which are 1 and 2 are different therefore ይሄ ፋንክሽን አይደለም but ዶሜኑ ምን ይሆናል አንድ አምስት እና ሁለት ዶሜኑ ሲሆን the range is 5 1 2 5 1 2 C this one that is 1 negative 2 negative 2 0 minus 1 2 and 1 3 ይህም ፋንክሽን አይደለም ምክንያቱም እዚህ ጋር the image of 1 is minus 2 again the image of 1 is 3 minus 2 is different from that of 3 so that due to the existence of these two elements this relation cannot satisfy the condition to be a function. And the last three that is minus 3 2 minus 3 is 3 3 minus 5 5 2 ይህም ፋንክሽን አይደለም ምክንያቱም minus 3 the image of minus 3 here is 2 and it has also another image that simply 3 and 2 is different from that of 3 so that በእነዚህ ሁለት ምክንያቶች ወይም ደግሞ ምክንያቱም የዶሜኑ አንዱ ኤለመንት ማይነስ 3 ከአንድ በላይ ኢሜጅ አላት 2 እና 3 ስለዚህ ይሄ ፋንክሽን ወይም ደግሞ ይሄ ሪሌሽን ፋንክሽን አይደለም ማለት ነው። when we justify this one በመጀመሪያው ለምሳሌ ይሄን ይመስላል ስለዚህ ፋንክሽን ነው the domain of this one is 1 2 3 and 4 and its range would be 1 2 4 5 1 to 4 5 Similarly, the second one that simply be ይሄ ምን አይደለም ይሄ ፋንክሽን አይደለም since 5 maps to both 1 and 2 5 1 5 2 that means then the given set is not a function ባይሆንም በሪሌሽኑ ዶሜን ምን ይሆናል ሲባል the domain is 1 5 2 or 1 to 5 and the range could be 5 5 1 2 or simply 1 to 5 again 1 to 5 again so that his domain and range of this relation which is not a function. The next one that is C we have this one therefore አሁንም ይሄ ምን አይደለም ፋንክሽን አይደለም ብለናል ምክንያቱም one has two images which are minus 2 and positive 3 therefore it is not a function anyways the domain is simply 1 negative 2 minus 1 minus 2 minus 1 1 minus 2 minus 1 1 and the range could be the range is minus 2 0 to 1 or in arranged form minus to 0 to 3 could be the range of this relation. Next or simply the last one we have this one ይሄንን ምን አይደለም ብለናል ፋንክሽን አይደለም ምክንያቱም minus 3 ሁለት ኢሜጅ ነው ያለው 2 እና ፖዚቲቭ 3 which are different ስለዚህ ፋንክሽን አይደለም ባይሆንም ግን ዶሜን እና ሬንጅ ምን ይሆናል ሲባል the domain is minus 3 positive 3 and 5 that is the domain is minus 3 positive 3 and 5 and the range could be positive 2 3 negative 5 and positive 2 again that means minus 5 positive to 3 minus 5 positive to 3 Okay. Question number 6. I did the question on compulsion function. Compulsion function. That means SOR or and ROS are composed of S እንድንፈልግ ነው የተጠየቅነው። The first one that is A, this one, R and S are given, B, this one. ስለዚህ እነዚህ ሁለት ጥያቄዎች ኮምፖዚሽን ፈንክሽን አስ ኮምፖዝድ ኦፍ አር እና አር ኮምፖዝድ ኦፍ ኤስ ምን ይመስላል ደግሞ እንዴት ይገኛል የሚለው ነው የምናየው ማለት ነው። ስለዚህ ከመጀመሪያው ስንነሳ we have R in this one containing two order pairs, S has also two order pairs. ስለዚህ ምንድን የጠየቅነው እዚህ ጋር by definition first S composed of R means if in the set containing an element of this one that is xz, so that this xz could be an element of this one is composed of R if there is y containing the order pair that is xy which is an element of R and yz is an element of z. ስለዚህ S composed of R ማለት እዚህ R ላይ ኤክስ ዋይ የሚባል ኤክስን ከዋይ ጋር ማፕ የሚያደርግና እንደገና ደግሞ ኤስ ዋይን ተቀብሎ ከዜድ ጋር ማፕ የሚያደርግ ከሆነ so that xz could be one of the possible elements of S composed of R. በነገራችን ላይ ይሄ ብራስ እዚህ ነበር መዘጋት የነበረበት። ይሄ ብራስ እዚህ እንዳለ አስቡት። ስለዚህ አንዱ ይሄ ነው። ሁለተኛው ደግሞ in component wise S composed of R of x means S of R of x ያ ማለት መጀመሪያ ይሄ R xን ወደ ሆነ ቦታ ይወስደዋል። ከዛ ደግሞ from the image of this one that is x under R so that we can find the image of this one that is simply the image under S. ስለዚህ S composed of Rን በምንፈልግበት ጊዜ S composed of Rን በምንፈልግበት ጊዜ we can start from the inner function here is R because R maps positive 2 to 3 and S maps to that of 3 and 4 so that S composed of R could be this one that is simply to 3 and to 4. ያው እንዴት ነው የሚገኘው ተመልከቱ እዚህ ጋር R the image of 2 under R could be the image of 2 under R is 3 ስለዚህ ይሄ 3 the image of 2 under R could be this one that simply 2 is mapped to 2 and then the image of 2 under S could be 3 so that 2 3 could be the element of S composed of R. Similarly within R the image of this one that simply 2 under R is 2 and the image of 2 under S is also 4 so that 4 could be an element of S composed of R. Then when we interchange the position of S and R, that is R composed of, also because output of S are not inputs in R, we have R composed of S is empty set. ምክንያቱም ለምሳሌ ከዚህ ከኤስ ላይ ስንነሳ the image of 2 under S is 3 but 3 doesn't have an image under R, or the image of 2 under S is 4, 4 doesn't have any image, so that R composed of S is empty set. Next B, R is this one and S is given here. ስለዚህ S composed of R ምን ይሆናል? Let us start from R. We know that the image of 1 under R is 2 and the image of 2 under S could be 3 so that 1 3 must be an element of S composed of R. Similarly again the image of 1 under S under R is 3 and the image of 3 under S is 5 so that 1 5 must be an element of S composed of R, 1 5 here. And the other could be the image of this one that's simply 1 under R is 2 and the image of 2 here is again 4 so that 1 4 must be an element of S composed of R. And lastly the image of 5 under R is 7 and the image of 7 under S is 1 so that 5 1 must be an element of S composed of R. Therefore S composed of R could be this with this element that's simply 1 3 1 4 1 5 and 5 1. Similarly, R composite of S could be this one. That means ለምሳሌ እዚህ ጋር የሁለት ኢሜጅ አንደር ኤስ ሶስት ነው። ሶስት ግን እዚህ ኢሜጅ የለውም። ስለዚህ two cannot be an element of or simply cannot be found within the domain of R composite of S. ኦኬ ሁለትም እዚህ ጋር የለም። ሶሪ የለም to four እዚህ የለም ኢሜጅ የለውም። therefore we cannot include two within as the element of the domain of R composite of S. እዚህ ጋር ስንመጣ the image of 3 under S is 5 and the image of 5 under R is 7, so that 3, 7 could be one of the possible elements of R composite of S. Okay, ስለዚህ አንዱ ኤሌመንት ይሆናል። ሁለተኛው the image of 7 under S is 1 and the image of 1 under R could be 2, so that 7, 2 is an element of R composite of S. And also the image of 1 under R is this one, that's simply 3, so that 7, 3 could be an element of this R composite of S. ስለዚህ የR composite of S ኤሌመንቶች set containing 3, 7, 7, 2 and 7, 3 ይሆናሉ ማለት ነው። Okay, next using that formula በሚሰጠን ጊዜ let f of x is 2x square minus 3 and g of x is x plus 1. ስለዚህ ይሄ ኦኬ ኦፕሬሽን ኦን ፋንክሽን የተጠየቅ ነው። መጀመሪያ የምንተጠየቅን እዚህ ጋር f plus g of 2 f times g of negative 2 g over f of 3 f plus g of x f times g of x g over f of x fog ጎፍ ፎግ and ጎፍ again። ስለዚህ እነዚህ እናያለን ማለት ነው። አሁን ሁለት ነው ኦፕሬሽን እና ኮምፖዚሽን using that formula። ኦኬ የመጀመሪያው ለምሳሌ f of x is equal to 2x square minus 3 g of x is x plus 1 is given። ስለዚህ ከዚህ ከተሰጠን በኋላ ምንድነው የተጠየቅነው? f plus g of 2. We know that by definition f plus g of 2 ማለት f of 2 plus g of 2 ነው. But f of 2 is, if we substitute 2 in the place of x here, it becomes 2 times 2 square. That is 2 times 4, which is 8. 8 minus 3 could be 5. And g of 2 could be, if we substitute 2 in the place of x here, 2 plus 1, that's simply 3. Therefore, f plus g of 2 could be 5 plus 3, which is 8. Similarly, f times g of minus 2 could be f of minus 2 times g of minus 2. But f of minus 2 could be minus 2 square is 4. 4 times this one, that's simply 4 times 2 is 8. 8 minus 3 could be 5. And g of minus 2 would be minus 2 plus 1, that's minus 1. Therefore, this is minus 5. Therefore, f times g of minus 2 is minus 5. And lastly, g over f of 3 could be, g of 3 over f of 3. G of 3 over 3 is equal to sign መኖር አለበት እዚህ ጋር g of 3 ማለት we have, if you substitute 3 here, we can have 3 plus 1, that's simply 4. And f of 3 could be, this f of 3 means 3 square is 9. 9 times 2 is 18. 18 minus 3 could be 15. So that 4 over 5 would be the image of 3 under g over f. Under g over f. Okay. Next. That is when f of x equal to 2x cubed, 2x square minus 3 and g of x x plus 1, the same function. ነገር ግን የተጠየቅነው ወይም ደግሞ የምንሰራው እዚህ ጋር ኦፕሬሽኑና ኮምፖዚሽኑ ይለያያል። Then f plus g of x, using that formula, we know that f plus g of x is simply the same as f of x plus g of x. And if we substitute the terms of f of x and g of x in the place of the functions here, we can have 2x square minus 3x, that is f of x, and plus x plus 1, which is g of x. So that this could be 2x square plus x minus 2, I think. 2x square minus x minus 2 could be the formula for f plus g of x whenever f of x is 2x square minus 3 and g of x is x plus 1. Next, f times g of x. f times g of x is simply by definition, it is f of x times g of x. ስለዚህ እነዚህን ተርሞችን f of x ላይ እና g of x ላይ ስንተካ we have 2x square minus 3 times x plus 1 and the product of these two binomials could be this one that is 2x cubed plus 2x square minus 3x minus 3 ይህን ማባዛት ነው በቀጥታ። Next, g over f of x is equal to, that is g of x over f of x. Therefore, using simple substitution, we have x plus 1 over 2x squared minus 3. And next one, that is f composite of g of 2. F composite of g of 2, by definition, it is f of g of 2. But what is g of 2 here is? G of 2 is 3, so that's f of g of 2 is equal to f of 3, but f of 3 is this one, that's 15. And the last one, g composite of f of radical 2, is by definition, it is g of f of 2, but f of radical 2, I mean. But f of radical 2 could be, if you substitute radical 2 in the place of x within f of x here, the square of radical 2 is 2, 2 times 2 is 4, 4 minus 3 could be 1, so that is g of 1, but g of 1 is 1 plus 1, which is 2. Therefore, g composite of f of radical 2 is exactly equal with this one, which is 2. Next question, f of x given to be, and this one that's 2x squared minus 3 again, and g of x, x plus 1, then we are asked just to find f composite of g. F composite of g of x is equal to f of g of x, which is f of x plus 1, because g of x is x plus 1. ስለዚህ የዚህ ፋንክሽን ወይም ደግሞ ጌን ካገኘን በኋላ ወደ f of x በምንመጣበት ጊዜ if the image of this input that simply x under f is 2x squared minus 3, so what would be the image of x plus 1? ስለዚህ f of x ምንድነው የሚያደርገው? የተሰጠውን ስኩዌር ያደርጋል፣ ከዛ በሁለት ያባዛል፣ ከዛ በሶስት ይቀንሳል። ስለዚህ አውትፑቱ ይሄ ነው። ኢንፑቱ x ሲሆን 2x squared minus 3 is the output. ስለዚህ ኢንፑቱ x plus 1 ቢሆን ምን ይሆናል ነው። ስለዚህ ምንድነው የሚሆነው? I think it is just 2 into x plus 1 square minus 3. That is 2 into x plus 1 square minus 3, because this one is g of x. So that the simplified form of this one could be 2x squared plus 4x minus 1. Therefore, f composite of g of x, whenever f of x is this one and g of x is this one, could be 2x squared plus 4x minus 1. Next, g composite of f of x could be g of 2x squared minus 3, which is equal to 2x squared minus 3 plus 1. ምክንያቱም g of x ምንድነው የሚያደርገው? የተሰጠው ኢንፑት ላይ አንድ ጨምሮ ነው አውትፑቱን የሚያወጣው፣ ወይም ደግሞ አውትፑቱ ከኢንፑቱ አንድ መጨመር ነው። ስለዚህ ኢንፑታችን 2x squared minus 3 ቢሆን ምንድነው የሚሆነው? አውትፑቱ 2x squared minus 3 plus 1 ይሆናል። 2x squared minus 3 plus 1 ደግሞ 2x squared minus 2 ይሆናል ማለት ነው። So that g composite of f of x equal to 2x squared minus 2 ይሆናል። Next question, question number 8. For the functions g of x equal to the square root of x minus 1 and h of x equal to x squared plus 1, we are asked just to find the domain of g composite of h of x. ስለዚህ ይህንን የዚህን ዶሜን g composite of h of x ዶሜንን ለመፈለግ ምንድነው የምናደርገው? መጀመሪያ we need to find the expression for this composition function. ስለዚህ g composite of h of x equal to g of h of x, but h of x in this case is x squared plus 1, so that this is equivalent with g of x squared plus 1. ስለዚህ g of x squared plus 1, but the output of this x under g could be, it is just the square root of the input minus 1, so that the head equivalent with the square root of x squared plus 1 minus 1, which is equal to the square root of x squared. Therefore, this is g composed of h of x. ስለዚህ g composed of h of x ይሄ ከሆነ የዚህ ዶሜኑ ማን ይሆናል ሲባል this is always positive, so that this is always defined for any real number, so that set of real number could be the domain for g composed of h of x. Since x squared is greater than or equal to 0 for all real numbers, so that the set of real number could be can be considered as the domain of the given function. Question number 9. Which of the following functions are one-to-one function and on-to? ደግሞ ስለ one-to-one እና on-to function ስለዚህ የተሰጡን ፋንክሽኖች አሉ። ስለዚህ ከነዚህ ውስጥ one-to-one የትኛው ነው፣ on-to የትኛው ነው፣ ወይም ደግሞ one-to-one correspondence ወይም ሁለቱንም የሚያሟላ የትኛው ነው የሚለውን ማየት እንሞክራለን ማለት ነው። ስለዚህ ለመጀመሪያው ስንነሳ we are given this point that is f of x equal to 6x minus 1. ስለዚህ ፋንክሽን one-to-one መሆኑና on-to መሆኑን ቼክ ለማድረግ ምንድን ነው የምናደርገው? መጀመሪያ ዴፊኒሽኑን ማስታወስ ያስፈልጋል። A function f which defined from a to b is said to be one-to-one if f of x1 is equal to f of x2 implies x1 is equal to x2. ይሄ ሎጂካል ኢምፕሊኬሽን ሁሉ ጊዜ እውነት ከሆነ ማለት f of x1 እና f of x2 እኩል ከሆኑ ሁሉ ጊዜ x1 እና x2 እኩል ከሆነ for n x1 and x2, it is just say x2 within a in the domain of the given function, then the function is said to be one-to-one function. ነገር ግን ይሄ ፎልስ ከሆነ ያ ማለት ነው ይሄ ፎልስ የሚሆነው መቼ ነው? ይሄ f of x1 እና f of x2 እኩል መሆናቸው ትሩ ሲሆንና x1 እና x2 የተለያዩ ከሆኑ ስለዚህ ሁለት የተለያዩ የዶሜኑ ኤሌመንቶች ተመሳሳይ ኢሜጅ ኖራቸው ማለት ነው። በዚህ ጊዜ ይሄ ፋንክሽን one-to-one ፋንክሽን አይባልም ወይም ደግሞ ሊሆን አይችልም ማለት ነው። ስለዚህ based on this criteria ይህን ሜጀር በምናደርግበት ጊዜ the function that is f of x equal to 6x minus 1 is linear with non-zero slope, which is strictly increasing function. That means በነገራችን ላይ ማንኛውም strictly increasing function ወይም ደግሞ strictly decreasing function ሁሉ ጊዜ one-to-one ነው። one-to-one ብቻ አይደለም, it is also an on-to function. ስለዚህ hence it is an increasing function. Therefore, the given function that simply 6x f of x equal to 6x minus 1 is both one-to-one and on-to function. It is on-to function. We have this remark. Every strictly increasing function is one-to-one function and it is also an on-to function. It is also an on-to function. Next one, that's simply b, f of x equal to x squared plus 7 is given. ስለዚህ ይሄን one-to-one እና on-to መሆኑን ቼክ ማድረግ ነው። ስለዚህ f of x ዲፋይን የተደረገው የቱ ጋር ነው? I think it is from r to r ነው። from r to r። ስለዚህ ይሄ ፋንክሽን ለምሳሌ ይሄ ፋንክሽን one-to-one አይደለም። ለምን ሲባል because ለምሳሌ if you take -2 and +2 or -1 and +1, f of -1 and f of -2 are the same, that's simply 1. ስለዚህ ይህ ሎጂካል ኢምፕሊኬሽን ፎልስ ሆነ ማለት ነው። ምክንያቱም f of 1 እና f of 2 ሁለቱ እኩል ናቸው፣ ትሩ ነው ይሄ። ነገር ግን አንድና ኔጌቲቭ 1 ሁለቱ እኩል አይደሉም፣ ይሄ ፎልስ ነው። ስለዚህ ፎልስ ኢምፕላይስ ትሩ፣ ፎልስ ሆነ። therefore this function is not one-to-one function. ፋንክሽኑ ኦንቱም አይደለም። ለምንድን ነው ኦንቱ የማይሆነው? ምክንያቱም ፋንክሽኑ ዲፋይን የተደረገው from set of real number into set of real number r to r ነው። ስለዚህ አንድ ፋንክሽን ኦንቱ ነው የሚባለው ይሄ ፋንክሽን ለምሳሌ from a into that of b ኦንቱ የሚሆነው መቼ ነው? if and only if every element of the codomain of this function, that simply b, is at and primate for at least one element within the domain of the given function. ወይም ደግሞ የዶሜኑ ወይም ደግሞ የዚህ የፋንክሽኑ ሬንጅ ከኮዶሜኑ ጋር እኩል ሲሆን ማለት ነው። ስለዚህ የዚህ ዶሜኑ ምንድነው የሚሆነው? the domain of this one ምክንያቱም ይሄ ሁሉ ጊዜ 0 ወይም ደግሞ ፖዚቲቭ ነው x greater than or equal to 7 in the domain, but the codomain is a set of real number, so that the codomain and the domain of this function are not the same, so that the function is not an onto function. because the range is 7 to positive infinity, which is different from that of the codomain of the given function that is simply R, so that the function is not one-to-one and on that it is neither of the two. It is neither. Next, question number C. We are given f of x equal to x plus 1 over x minus 7. ስለዚህ f of x1 is equal to f of x2 implies x1 is equal to x2. ይህን further simplify ማድረግ ይቻላል። This is always true for the domain of the given function, which is set of real number without 7. ስለዚህ for all x1 and x2, hence the function is one-to-one function. ኦንቱ መሆኑን ለማሳየት ግን ማለት አለብን from set of real number without 7 to r ነው ዲፋይን የተደረገው። ስለዚህ ኦንቱ የሚሆነው መቼ ነው? for any real number must be a pre-image or simply an image for at least one element within the range of, within the domain of this function, that is domain of f ሲሆን ነው። ስለዚህ ይህን ሲምፕሊፋይ በምናደርግበት ጊዜ but the function is not unknown because ለምሳሌ y is equal to x plus 1 በምንልበት ጊዜ over x minus 1 ለx solve ብናደርግ we have this one. Sorry, this must be y. This must be this y. ስለዚህ x equal to 8 over y minus 2. ስለዚህ አሁን እዚህ ጋር y ማለት the range, possible range of this function is the set of real number without 2. ነገር ግን function define የተደረገው from r to r ነው። ስለዚህ from r to r ከሆነ define የተደረገው የዚህ function range ከኮዶሜኑ ጋር የተለያየ ሆነ ወይም ደግሞ ምን ማለት ነው? within the codomain of the given function or the range of the given function 2 cannot be the image of any real number. So that in this case, the function cannot be an onto function. It is not onto. Therefore, this means that it is impossible to get a pre-image for y is equal to 2, so that the function is not onto function. It is not on function. Okay, let's continue. Next question. f of x equal to x cubed is given. Therefore, the function is strictly increasing on set of real number. So it is the node function. And ቅድም ብለናል ማንኛውም strictly increasing function onto function ነው onto one-to-one ነው። Therefore, the function is both one-to-one and it is an onto function. And the last one, that is a f of x equal to absolute value of x is given. It is not one-to-one function. We know that the image of, for example, any two opposite numbers is the same. So that it cannot be one-to-one function. This is simple counter example. F of 2 and f of minus 2 are the same, or f of minus 1 and f of positive 1 are also the same, so that it is not one-to-one function. Function onto አይደለም ምክንያቱም the function defined from r to r, but the domain of this function, the domain set of real number, but the range is always non-negative real number. ስለዚህ ኔጌቲቮቹ ለማንኛውም real number ኢሜጅ መሆን አይችሉም። ስለዚህ ይሄ function onto function ሊሆን አይችልም ማለት ነው። It is not onto because negative numbers are not in the range of the given function, or negative numbers cannot be an image for any element within the set of real number, or simply within the domain of the given function. Question number 10. Find the inverse of each of the following functions. We are given about 3 functions, and we are asked just to find the formula for the inverse of the given function. Let us start from the first one, that is h of x equals to x minus 3 is given. ስለዚህ መጀመሪያው ምንድነው የምናደርገው? ፕሮሲጀሮች አሉን። Let, for example, the image of x under h is y. ስለዚህ h of x equals to x minus y can be expressed as, or simply will becomes y is equal to x minus 3. ከዛ ምንድን ነው የምናደርገው? we can exchange or simply swap the variables, simply replacing x in the place of y and y in the place of x, and we can have here that is x equal to 3y minus 3. ስለዚህ ይሄ ኢኩዌዥን ከየት የመጣው? ከዚህ ነው። ምን በማድረግ ኤክስ እና ዋይን ስዋፕ በማድረግ ወይም ደግሞ ቦታቸውን በማቀያየር ከዛ በኋላ ለአዲሱ ቫሪያብል ለዋይ ሶልቭ እናደርጋለን። ሶልቭ በምናደርግበት ጊዜ ይህን ወደዚህ እንወስዳለን። it becomes x plus 3 both sides ለሶስት ስናካፍል we can have y is equal to x plus 3 over 3. So by assuming that x is an independent variable, the usual independent variable for the expression of any function, so that in this case the inverse of the given function, that is f inverse of x, h inverse of x is equal to x plus 3 over 3, x plus 3 over 3. Next to be h of x given to be 2x cubed plus 3, so that the inverse of this function could be, again let h of x is y, so that we have y is equal to x cubed plus 3. ስለዚህ በቀጥታ አሁን እዚህ ጋር ቫሪያብሎቹን ሪፕሌስ ሳናደርግ ወይም ደግሞ ስዋፕ ሳናደርግ ኤክስቼንጅ ሳናደርግ ለኤክስ ሶልቭ በማድረግም ኢንቨርሱ መፈለግ ይቻላል። ለምሳሌ ለኤክስ ሶልቭ በምናደርግበት ጊዜ እዚህ ጋር both sides ሶስትን ስንቀንስ we can have y minus 3 is equal to 2x cubed። ከዛ ለኤክስ አር ሶልቭ ማድረግ የፈለግነው ለሁለት ስናካፍል we have ለሁለት ካካፈልን በኋላ ኪዩብሩትን both sides ኪዩብሩት በምንወስድበት ጊዜ x is equal to the cube root of y minus 3 over 3 ይሆናል። Therefore the inverse of this function, that is h inverse of x, could be just this one, that is the cube root of x minus 3 over 2. Okay, next question. That is question number 3. C. G of x is given to be 1 over 5x plus 2. Therefore, y could be, that is letting g of x to be y, 1 over 5x plus 2 አለን። ስለዚህ ይህንንም ለx ሶልቭ በምናደርግበት ጊዜ ሁለትን both sides ስንቀንስ we have y minus 2 is equal to 1 over 5x. And multiplying both sides of this equation by 5, we have x equal to 5 into y minus 2. Therefore, h inverse of x could be, g inverse of x could be 5x minus 10, that is distributing this one over here. We can have 5x minus 10 will be directly the inverse of this function. Okay, ሌላው እዚህ ኢንቨርስ ፋንክሽን እና ፋንክሽን ወይም ደግሞ ኢንቨርስ ላይ ማወቅ ያለብን ነገር ምንድን ነው? ለምሳሌ if g inverse of x, this one is the inverse of this function, የዚህ ፋንክሽን ዶሜን ማለት ለዚህ ለኢንቨርሱ ሬንጅ ይሆናል። የዚህ የሬንጁ ዶሜን ማለት ደግሞ ለኦሪጂናል ፋንክሽን ለጂ ኦፍ ኤክስ ዶሜን ይሆናል ማለት ነው። ሬንጅ ይሆናል ማለት ነው። ስለዚህ ዶሜን እና ሬንጅ እንደዛው ተቀያይረው የሚገኙ መሆኑን ማስታወስ ተገቢ ነው ወይም ደግሞ ጠቃሚ ነው። ኦኬ let's continue. Question number 11. We are asking just to find the range of g of x equal to 2x plus 1, f of x equal to x plus 1 over 2x minus 1, h of x equal to the square root of x plus 4 minus 3. ስለዚህ ሬንጅ ነው የተጠየቅነው። ስለዚህ ከመጀመሪያ ከጂ ኦፍ ኤክስ በምነሳበት ጊዜ g of x equal to x plus 1 is given. Therefore, the function is linear function, and it is linear, and linear functions take all real numbers or simple real values, or they are one-to-one in that of onto functions. Therefore, the range could be a set of real number. The range is set of real number, or every real number could be an image for at least one real number within the domain of the given function, that set of real number, since it is a strictly increasing or simply increasing function. B, f of x equal to x plus 1 over 2x minus 1 is given. ስለዚህ የዚህን ሬንጅ በምንፈልግበት ጊዜ the range could be, that is possible value of y ነው ወይም ደግሞ ኢሜጆቹ ማለት ነው። ስለዚህ y is equal to x plus 1 over 2x minus 1 ቢሆን ይህንን ለx ሶልቭ በምናደርግበት ጊዜ we can have this one, that is x into 2y minus 1 is equal to y plus 1, or x is equal to y plus 1 over 2y minus 1. ስለዚህ the domain of this one or the possible value of y here could be all the possible values of y could be the range of the given function. ስለዚህ 2y minus 1 non-zero መሆን አለበት and it could be non-zero whenever y is different from that of 1 over 2. Therefore, the range could be the set of real number that can, without the set containing set of real number that can make 2y minus 1 is 0. Therefore, y different from that of 1 over 2 could be the range of the given function. Okay, see, h of x equal to the square root of x plus 4 minus 3 is given. ስለዚህ ይህንን በምንወስድበት ጊዜ h of x is positive or simply greater than or equal to 0, and we have minus 3 here. Therefore, we have h of x is greater than or equal to the possible or simply the range of this one minus 3, which is greater than or equal to minus 3. Therefore, the range could be the interval from minus 3 to positive infinity. Next, use the division algorithm just to divide this one x cubed plus 2x squared minus 5x plus 6 by x squared minus 2, and the second one is apply the remainder theorem to find the remainder when f of x equal to 2x cubed minus 3x squared plus 4x minus 5 is divided by linear polynomial function of x minus 1. So let us start from the first one. Using log division methods, we have this one that is leading coefficienቶቻቸውን በምናካፍልበት ጊዜ የመጀመሪያው ተርም ለማግኘት x cubed over x squared is x. Then x cubed plus 2x squared minus 5x plus 6 minus this x multiplied by the denominator. Denominator በዚህ በኮሸንቱ አባዝተን ከዚህ ላይ ስንቀንስ ይሄን እናገኛለን. That means we have 2x squared minus 3x plus 6. Okay, ስለዚህ ይሄ ተቀንሶ ይሄን አግኝተናል. This is the first remainder which is obtained here. ከዛ በኋላ እንደገና አሁንም ይሄንን ለዚህ ለx square minus 2 በምናካፍልበት ጊዜ የዚህ ሊዲንግ ተርም ለዚህ ለታችኛው ሊዲንግ ተርም በምናካፍልበት ጊዜ2x square over x square is 2 ይሆናል። ስለዚህ 2 ከሆነ አሁን ከዚህ ከ2x square minus 3x plus 6 ላይ 2 times the denominator that is 2 times x square minus 2 መቀነስ አለበት። ስለዚህ ስንቀንስ 2x square minus 3x plus 6 minus 2 into x square minus 2 would be simplified to this one that is minus 3x plus 10. Hence, ይሁን ሪሜንደር ነው ምክንያቱም የዚህ ዲግሪ ከዲቫይደሩ ከx square minus 2 ዲግሪ ያንሳል። ስለዚህ ይሄን minus 3x plus 10 ለx square minus 2 ማካፈል አንችልም. So that this could be exactly the remainder which is obtained from the division. Minus 3x plus 10. Thus, the quotient is the terms that are obtained, the first one x, እንደገና ደግሞ አሁን ሁለትን አግኝተናል። ስለዚህ x plus 2 is the quotient polynomial function, and the remainder is this one. Therefore, hence this one, the denominator of the given fraction, that is x cubed plus 2x squared minus 5x plus 6, can be expressed as using polynomial division algorithm. That means x cubed plus 2x squared minus 5x plus 6 is equal to x plus 2, the quotient polynomial function, times the divisor that is x squared minus 2 plus the remainder which is minus 3x plus 10. Minus 3x plus 10. Therefore, this is the process. Next question, question number B. We are asked just to find the remainder when f of x, this expression, is divided by x minus 1. We have this remark, the remainder theorem about. The remainder theorem stated that when a polynomial f of x is divided by the linear polynomial function of this form that is x minus a, the remainder is always f of a. ስለዚህ ይህ ፖሊኖሚያል ፋንክሽን ለx minus 1 በሚካፈልበት ጊዜ የሚገኘውን ሪሜንደር በሪሜንደር ቴረም ለማግኘት you only substitute r in this case is 1, that is 1 in the place of x here. ስለዚህ r is equal to f of 1, f of 1 ማለት directly if you substitute 1 within 4x within the terms of f of x here, we have 2 times 1 cubed minus 3 times 1 squared plus 4 times 1 minus 5, which is equal to negative 2. Negative, so that the remainder when this polynomial function divided by x minus 1 would be this one, that is minus 2. Therefore, it is minus 2 and the remainder is minus 2. Next, that is C. We are asked just to verify whether x minus 3 is the factor of f of x is equal to x cubed minus 7x plus 6 or not using the remainder theorem. ስለዚህ ሪሜንደር ቴረም አንድ ፖሊኖሚያል ፋንክሽን ለዚህ አይነት ፖሊኖሚያል ፋንክሽን ወይም ደግሞ ሊኒየር ፖሊኖሚያል ፋንክሽን በሚካፈልበት ጊዜ የምናገኘው ሪሜንደር it could be f of r or simply in this case f of 3 ነው። ስለዚህ x minus 3 ለዚህ ፖሊኖሚያል ፋንክሽን ፋክተር ከሆነ ደግሞ the remainder which is obtained from dividing f of x by x minus 3 must be exactly equal with the 0 መሆን አለበት ፋክተር ከሆነ። ስለዚህ ፋክተሩ ደግሞ ሪሜንደሩ እና 0 ከሆነ ፋክተር አይደለም፣ ሪሜንደሩ 0 ከሆነ ግን ፋክተር ነው። ስለዚህ በቀላሉ በሪሜንደር ቴረም ሪሜንደሩን በምንፈልግበት ጊዜ let's compute the remainder using remainder theorem. We have r is equal to f of 3, which is equal to 27. That is, if you substitute 3 directly in the place of x here, minus 21 plus 6, which is 12. So that which is non-zero. Since r is equal to f of 3, which is different from that of 0, so that x minus 3 is not the factor of f of x. It is not the factor. የመጀመሪያው ጥያቄ ይሄ ይሆናል። that means it says use the location theorem to show that f of x is equal to x cubed minus 4x squared plus x 6 has a root between x equal to 0 and x equal to 1. ስለዚህ ይህን ጥያቄ በምንሰራበት ጊዜ ለዚህ ጥያቄ መልስ ቁልፍ ሊሆን የሚችለው ነገር ምንድነው? ሎኬሽን ቴረም ምን ይላል? ወይም ደግሞ ሎኬሽን ቴረም በሁለት ሪል ነምበሮች መካከል አንድ የሆነ ፋንክሽን ሩት እንዳለው ወይም ደግሞ እንደሌለው በምንድን ነው የምናውቅ የሚለውን እሱን ማስታወስ ያስፈልጋል። ስለዚህ እሱን ስናይ ይህን ቴረም እናያለን። ሎኬሽን ቴረም ምንድን ነው የሚለው? if f of a and f of b have opposite signs, then there exists at least one root in a and b. That means when a and b are any two real numbers, whether a is less than b or a is greater than b, and if the product of the functional values of this a and b with respect to the given function f of x has a negative or strictly less than 0, so that will be an indication for the existence of at least one root for the given function that is f of x እንዳለው ይጠቁመናል ማለት ነው። ስለዚህ ይህ ፋንክሽን በx equal to 1 እና x equal to 1 እና x equal to 0 ሩት አለ ወይም ደግሞ የለውም የሚለውን ለማወቅ ምንድነው የምናደርገው? we have to check by the sign of the functional values f of 0 and f of 1. If the sign of f of 0 and f of 1 are opposite, then that will be an indication, or the using location theorem guarantee that the existence of one root for this function in between 0 and 1. Therefore, we know that f of 0 is 6. If you substitute 0 in the place of x here, we have this one, that is 6, and f of 1 is equal to 1 minus 4 plus 1 plus 6, which is 4. So as we clearly observe here, both f of 0 and f of 1 have the same sign, which are both are positive, so that their product cannot be negative. Therefore, this indicates that since both are positive, there is no sign change. Therefore, the theorem doesn't guarantee a root in 0 to 1. ስለዚህ በዚህ በሎኬሽን ቴረም አማካኝነት f of 0 እና f of 1 ኦፖዚት ስላልሆኑ ሳይናቸው the same that is positive ናቸው ሁለቱም። ስለዚህ ይህ ሎኬሽን ቴረም ይህ ፋንክሽን በ0 እና በ1 መካከል ሩት እንዳለው ጋራንት አይሰጥም፣ ወይም ደግሞ መኖሩን አይጠቁምም ማለት ነው። ስለዚህ ሩት የለውም። ኦኬ ኔክስት ኩዌስችን apply location theorem to show to determine an interval containing a root of f of x equal to x cubed plus 2x minus 1 ስለዚህ አሁን ቅድም ሁለት ሪል ነምበሮች ተሰጥቶን በእነዛ ሪል ነምበሮች መካከል የተሰጠን ፋንክሽን ሩት አለ ወይስ የለውም ነበር ቼክ ያደረግነው። አሁን ደግሞ ምንድነው using the same theorem, that is location theorem, we are asked just to determine an interval containing the possible root of this polynomial function። ያ ማለት ሁለት ሪል ነምበሮችን ኤፍ ኦፍ ሁለት ሪል ነምበሮችን ነው የምንፈልገው ማለት ነው። ይህ ምን የሆኑ ፋንክሽናል ቫሊዎቹ ኦፖዚት የሆኑ አንዱ ኔጌቲቭ ሌላኛው ፖዚቲቭ የሆነ ማለት ነው። ስለዚህ ለምሳሌ just if I take f of 1, if I substitute 1 in the place of x here, we have 1 plus 2 minus 5, which is equal to negative 2. And another real number which is different from that of 1, probably which may give a positive number, could be this one, that's simply f of 2 to the power of 3 is 8, 2 times 2, that's simply 4 minus 5, this is 7. Then as we clearly observe here, f of 1 and f of 2 have different or simply opposite signs, because the first one is negative and this one is positive. ስለዚህ ቫሊያቸው ስንት እንደሆነ አይደለም፣ አንደኛው ኔጌቲቭ ሌላኛው ፖዚቲቭ ከመጣ so that using the quotient theorem, this indicates that f of x will have at least one root in between 1 and 2. Therefore, since the signs are opposite or simply their product, that is f of 1 times f of 2 is negative, that is minus 2 times 7, that means so that the function that is f of x will have at least one root in the interval that is 1 to 2. That means this function will have at least one root which is greater than 1 and less than 2. And this is guaranteed by this theorem, which is location theorem. Next question. Given that 2 plus I, the root of f of x equal to x cubed minus 4x squared plus 5x minus 2, then use the conjugate root theorem just to find another root. ስለዚህ ፋንክሽን አለኝ፣ የፋንክሽን ሰጥተናል። ለዚህ ፋንክሽን የኮምፕሌክስ ነምበር 2 plus I አንድ ሩት ነው። ስለዚህ we are asked just to find the conjugate root of this theorem። ስለዚህ ኮንጁጌት ሩት ለመፈለግ ምንድን ነው የምናደርገው? ኮንጁጌት ሩት ቴረም ምን ይላል የሚለው ማስታወስ ያስፈልጋል። ስለዚህ ምንድን ነው የሚለው? if a polynomial has real coefficients, that means if the coefficients of the polynomial function are all that are real numbers, and if we do have that simply for the given function, if a plus bi is the root of one of the possible roots of the given polynomial function, then the complex conjugate of this complex number, which is a minus pi, is also the root of the same polynomial function. ስለዚህ አሁን a plus pi እና a minus pi ምንድናቸው ከተባለ አንዱ የአንዱ ኮምፕሌክስ ኮንጁጌት ነው። ስለዚህ ይሄ ሪል ነምበር አይ ሚን ኮምፕሌክስ ነምበር ለዚህ ፖሊኖሚያል ፋንክሽን ሩት ከሆነ it is complex conjugate a minus pi must also be the other possible root of the same polynomial function። ስለዚህ ጋር ምንድነው የተሰጠን 2 plus I ለዚህ ፖሊኖሚያል ፋንክሽን ሩት ነው ተብለናል። ስለዚህ የዚህ ኮንጁጌት ሩት ማለት የዚህ ኮምፕሌክስ ኮንጁጌት that means 2 minus I ይሆናል ማለት ነው። Therefore 2 plus I the root of f of x, so that it is complex conjugate root is the polynomial, the complex number that is 2 minus I. Therefore the conjugate complex conjugate root of this polynomial function related to that of this one, which is the complex conjugate of this complex number, could be 2 minus I. Okay, if 3 minus 2i is the root of a polynomial with real coefficients, write down its conjugate root and construct a quadratic factor. ሁለት ጥያቄ ልጠየቅ ነው እዚህ ጋር። አንደኛ 3 minus 2i ሩት ከሆነ የአንድ ፖሊኖሚያል ፋንክሽን የሆነ ፖሊኖሚያል ፋንክሽን ኮምፕሌክስ ኮንጁጌት ወይም ኮንጁጌት ሩቱን ፈልጉ ተብለናል። ሁለተኛ ደግሞ using that of the combination of factor and remainder theorem 3 minus 2i እና የዚህ ኮምፕሌክስ ኮንጁጌት ሩት ሁለት ሩት አለው። ስለዚህ ሁለት ሩት ካለው የሁለቱ እያንዳንዳቸው ወይም ደግሞ ፋክተር የሚሆንበት አለው። ስለዚህ we need to determine the quadratic factor of the given or simply the expected polynomial function. Okay, first, the conjugate root is 3 plus 2i, which is the complex conjugate of the given complex number, which is 3 minus 2i. So that using the quadratic factor could be, on factor theorem apply ስናደርግ 3 minus 2i የአንድ polynomial function root ከሆነ x minus root 2i must be one of the possible linear factor of the given polynomial function. And again, from the conjugate root of the same polynomial function, 3 plus 2i, the root of the given polynomial function, therefore x minus 2 plus 2i, 3 plus 2i could be the other possible linear factor of the same polynomial function, so that the product of the linear factors of the given polynomial function will be the quadratic factor of the same polynomial function. Therefore, እነዚህ ፋክተር ሁለት ሊኒየር ፋክተሮች በምናባዛበት ጊዜ ምን እናገኛለን? This is just we have x minus 3 square plus 4, which can be further simplified as that is, I think, x square minus 6x plus minus 9 plus this one, that's simply 13. X square minus 6x plus 13 could be the possible quadratic factor of the given polynomial function when 3 plus 2i and 3 minus 2i are it is possible roots. Okay, next question number 14c. If p of 4 is equal to 0 and p of x is equal to 2x cubed minus 11x squared plus 10x plus 8, then find the remaining zeros. ስለዚህ እዚህ ጋር አንድ p of 4 is equal to 0 ይህ cubic polynomial function ነው. That means from the definition or simply property of polynomial function, ይህ polynomial function ሶስት distinct roots ሊኖሩት ይችላል. The maximum number of the roots of this polynomial function will be exactly equal with its degree, so that ሶስት ሊኖሩት ይችላሉ ማለት ነው። ስለዚህ ከነዚህ ከሶስቱ አንዱ ተሰጥቶናል። p of 4 is equal to 0 ከሆነ 4 could be one of the possible root of this polynomial function. And using that factor theorem, if p of 4 is equal to 0, we know that x minus 4 must be one of the possible linear factor of this polynomial function. ስለዚህ ስናካፍለው using polynomial division algorithm remainder 0 ይሆናል ማለት ነው። ስለዚህ since p of 4 is equal to 0, x minus 4 is the factor of this polynomial function. Therefore, this one, that's 2x cubed minus 11x squared plus 10x plus 8 can be expressed as x minus 4 times this quadratic equation. This quadratic equation could be obtained by dividing 2x cubed minus, or simply this cubic polynomial function, by x minus 4. This is already the quotient. The remainder is already 0 because x minus 4 is the factor of this cubic polynomial function. ከዛ በዚህ መልኩ ፋክተራይዝ ካደረግን በኋላ ሌሎቹን ሩቶቹን ለመፈለግ ቀሪ ሁለት ሩቶች አሉን። those roots could be the roots of this quadratic equation, or simply quadratic term, 2x squared minus 3x minus 2. So that the root of 2x squared minus 3x minus 2 can be, for example, easily obtained by using that factorization. 2x squared minus 3x minus 2 can be factorized as 2x squared plus 1 times x minus 2. ያ ማለት ይሄን ለመፈለግ እንደምናደርገው ስንደምራቸው minus 3 ስናባዛቸው ደግሞ minus 4 ነው የሚሰጡን። ሁለት ሪል ነምበሮች ነው የምንፈልግ, so that we can have this one, that is 2x plus 1 and x minus 2. ስለዚህ የዚህ ሩቶች ማለት x equal to negative 1 over 2, x equal to 2 አለኝ፣ እዚህ x equal to 4 አለኝ, which is given from the question itself. And therefore, p of 4 can be fully expressed as in the factorized form, x minus 4 times 2x plus 1 times x minus 2. Therefore, the roots of the given polynomial function could be, or the remaining roots could be, negative 1 over 2, the zero of this linear factor 2x plus 1 and 2, which is the zero of the last one, that is x minus 2. So that the other roots of, or simply the remaining roots of this polynomial function could be minus 1 over 22, and third could be as it is given here, that's simply 4. Okay, next, find a function f such that 1, 2, and 3 are roots with multiplicity 3 to 1 respectively. That means 1 is the root of the given polynomial function f with multiplicity 3 times. 2 is also the root of the same function with multiplicity 2, and 3 is the root of this one with multiplicity 1. And therefore, we just root with multiplicity means a root r with multiplicity m contributes a factor. That means the factor for the given polynomial function as x minus r to the power of m. Or if x minus r to the power of m is the factor of a certain polynomial function, then this real number that is r is said to be the root of the given polynomial function with multiplicity m times, when m is any positive integer. And therefore, the given polynomial function could be f of x can be x minus 1 to the power of 3, because just we are informed that 1 is the root of the given polynomial function with multiplicity 3 times. 2 is the root of this polynomial function with 2 times, multiplicity 2 times, so that x minus 2 to the power of 2 must be the other factor of the given polynomial function. And lastly, we have x minus 3 because 3 is the root of this polynomial function with multiplicity 1 times. Therefore, the expected function, that's simply the function who is roots 1 to 3, and with this multiplicity could be f of x equal to x minus 1 to the power of 3 times x minus 2 to the power of 2 times x minus 3. And expand ማድረግ እንችላለን. For example, if we are asked just to determine the degree of this polynomial function, the degree of the given polynomial function could be the sum of the multiplicities of the roots of the given polynomial function. ስለዚህ ይህ አሁን ዲግሪው ስንት ይሆናል ብንባል የእነዚህ የመልቲፕሊሲቲዎቹ ድምር ነው የሚሆነው ዲግሪው። ስለዚህ 3 አለኝ 2 5 እዚህ አንድ አለ 6 so that this could be a function with degree 6. Question number 15a. Use the rational root theorem to list all possible rational roots of this cubic polynomial function. ስለዚህ ራሽናል ሩት ቴረምን ማስታወስ ያስፈልጋል። እዚህ ጋር ራሽናል ሩት ቴረም ምንድን ነው የሚለው let f of x equal to this polynomial function with degree n and leading coefficient that's simply n, and be a polynomial with integer coefficients if all the coefficients of the terms of the given polynomial function that are n minus 1 up to this constant term that is n are positive integers, any integer, so that the given polynomial function is said to be a polynomial function over integers. So that this will be a criteria for applying rational root theorem or simple rational root test. And then if the given polynomial function that is f of x has a rational number which is written in the form of p over q, which is the root of f of x in lowest term. That means we know that this rational number could be in lowest term whenever the greater common divider or simply greater common factor of p and q is equal to 1. Then the rational root of f of x must be of the form plus or minus factor of the constant term divided by the factor of the leading coefficient. ስለዚህ ጋር ሊዲንግ ኮኤፊሽንት 2 አለኝ ኮንስታንት ተርም 3 አለኝ። ስለዚህ ይሄ ፖሊኖሚያል ፋንክሽን ራሽናል ሩቶች ካሉት the possible rational roots of this polynomial function must be a rational number which is plus or minus the possible factors of the constant term, that's 3, divided by the possible factors of the leading coefficient of this polynomial function, which is 2. Therefore, the rational roots could be this one, that's plus or minus 1, plus or minus 3, plus or minus 1 over 2, plus or minus 3 over 2, which is the combination of the factors of the constant term, which is 3, and the factors of the leading coefficient, which is 2. Question number 15b, that is the next question. Apply the rational root theorem to find all rational roots of f of x equal to this cubic polynomial function and factorize the polynomial completely. Okay, the possible rational roots are, we know that in the first case, the polynomial function is, it is a polynomial function over integers. ምክንያቱም ሁሉም ተርሞቹ ወይም ደግሞ ኮፊሽንቶቹ ኢንቲጀሮች ናቸው። ስለዚህ the constant term here is minus x, the leading coefficient is 1. ስለዚህ if we combine the possible factors of 6 with the possible factors of the leading coefficient of this polynomial function, which is 1, the possible rational roots are becomes plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. ስለዚህ ይሄ ፖሊኖሚያል ፋንክሽን ራሽናል ሩቶች ካሉት እነዚህ ከስምንቱ ውስጥ አንዱ ሊኖረው ይችላል፣ ሁለት ሊኖረው ይችላል፣ ሶስት ሊኖረው ይችላል። ሁሉም ራሽናል ሩቶች ከሆኑ ማለት ነው። ስለዚህ ከሌለው ራሽናል ሩት ከሌለው ግን ከነዚህ ውጭም ቢሆን አይኖረውም ማለት ነው። so that these are the only possible rational roots of this cubic polynomial function. ኦኬ ከዚህ በኋላ ከነዚህ ውስጥ የትኞቹ ናቸው የሚሆኑ ስንል እነሱን ለመለየት ምንድነው ቼክ ማድረግ ነው። by substituting the individual possible rational roots in the place of x here, we can check whether the given rational number or simple roots or possible root can make the given polynomial function to be zero or nonzero. ስለዚህ based on this fact, if we check 1, for example, f of 1 is exactly 0. If we substitute 1 here, we have 1 minus 6 plus 11 minus 6, which is 0. So that f of 1 0 ሆነ ማለት one of the possible rational root of this polynomial function is 1. And by using that factor theorem, if f of 1 is equal to 0, or simply remainder theorem, f of 1 is equal to 0, x minus 1 must be the factor of the given polynomial function. So therefore, if we divide this one and fully, the given polynomial function can be written as f of x equal to x minus 1 times x squared minus 5x plus 6. ይህ እንዴት ነው የሚገኘው? ይህን ፖሊኖሚያል ፋንክሽን f of xን ለዚህ ሊኒየር ፋክተር x minus 1 ስናካፍል ምክንያቱም x minus 1 የዚህ ፖሊኖሚያል ፋንክሽን ፋክተር ስለሆነ ሪሜንደር አይኖረውም። ስለዚህ f of x በዚህ ሊኒየር ፋክተር እና በዚህ ኳድራቲክ ተርም ወይም ደግሞ ፋክተር x squared minus 5x plus 6 ይሄ ማለት ይሄንን ለዚህ ለx minus 1 ስናካፍል የሚገኝ ኮሸንት ፖሊኖሚያል ፋንክሽን ማለት ነው። በዚህ መልክ ይጻፋል። And again, if we try to factorize again x squared minus 5x plus 6, we have this one that is x minus 2 times x minus 3. ያ ማለት ሁለት ሪል ነምበሮችን መፈለግ ነው። ስንደምራቸው minus 5 ስናባዛቸው ደግሞ positive 6 that are minus 2 and that are minus 3. Therefore, fully the factorized form of x squared minus 5x plus 6 could be this one. Therefore, the given polynomial function that is f of x can be expressed as x minus 1 times x minus 2 times x minus 3. Therefore, from the factorized form of this polynomial function, the roots of this polynomial function could be the zeros of the individual linear factors, so that x equal to 1, 2, and 3 would be the roots of this, the zeros of the given polynomial function. That means here the roots are 1, 2, and 3 from this factorized form. Okay, next. 16a, find all rational roots of f of x equal to x cubed minus 4x squared minus 7x plus 10 and sketch the graph of the given polynomial function. ስለዚህ ጥያቄ ደግሞ ከቀደም እስካሁን ካየናቸው ምንድነው ልዩ የሚያደርገው ራሽናል ሩቶቹን እንፈልጋለን። እንደገና ደግሞ በተጨማሪ ደግሞ we are asked just to sketch the graph of the given polynomial function. Therefore, first, the roots of the given polynomial function are, we know that fully the factorized form of this polynomial function could be f of x equal to x minus 1 times x minus 5 times x plus 2, so that the roots of this polynomial function could be x equal to 1, 5, and negative 2. And the roots are 1, 5, and negative 2, which are directly obtained from this linear factorization. But in order to draw the graph of the given polynomial function, we need to find the intercept, that is the x-intercept and the y-intercept. Actually, in the case of that of a polynomial function, the x-intercept of the graph of the given polynomial function means it is the point at which the graph of the given polynomial function is intersecting the horizontal axis or x-axis, and this pointers could be just the zeros of the given polynomial function. Therefore, the x-intercept of this polynomial function could be 1, 0, 5, 0, and negative 2, 0. Because the x-intercepts are the roots of the function, and its y-intercept is the constant term of this one. And therefore, the x-intercepts are minus 1, 0, 5, 0, and negative 2, 0. And its y-intercept could be, that is when x equal to 0. So that this expression will be 0 and only 10 will be left. So that 0, 10 would be its y-intercept. ያ ማለት ነው የዚህ ፖሊኖሚያል ፋንክሽን ግራፍ ኤክስ አክሱ እነዚህ ሶስት ፖይንቶች ላይ ቆርጠዋል፣ ዜሮዎቹ ላይ ማለት ነው። ዋይ አክሱን ደግሞ አንድ ፖይንት ላይ ብቻ ነው የሚቆርጠው። ማንኛውም ፖሊኖሚያል ፋንክሽን ኮንስታንት ተርም ሄር ኢዝ 10 ሶ ዛት 0 10 would be its y intercept። ሌላው እዚህ ጋር ስለ ፖሊኖሚያል ፋንክሽን ግራፍ በምናወራበት ጊዜ የፖሊኖሚያል ፋንክሽን ግራፍ ምንድነው ከተባለ it is the smooth curve and the graphical or simply the turning poinቶች አሉት። the maximum number of turning point of the given polynomial function could be n minus 1 when n is the degree of the given polynomial function። ስለዚህ ይህ ኪዩቢክ ፖሊኖሚያል ፋንክሽን ስለተሰጠን የዚህ ፋንክሽን ግራፍ ሁለት ተርኒንግ ፖይንቶች ሊኖሩት ይችላሉ። ቢያንስ አንድ ግን ይኖረዋል። ኦኬ አንድ ሊኖረው ይችላል። ሌላ እነዚህ ይሄ ዲግሪ ወይም ደግሞ ሊዲንግ ተርሙ ኤክስ ፓወር ኦፍ 3 that is the degree is 3 which is odd። ስለዚህ ሁለቱ የፋንክሽናችን ሁለቱ ጫፎች በተቃራኒው አንድ ወደ ታች ሌላኛው ወደ ላይ ነው የሚወጣው ማለት ነው። ኦኬ ስለዚህ based on this criteria ወይም ደግሞ ሌሎችን ቲፖችን እነዚህን ብናይ ለምሳሌ እዚህ ጋር ምን እናገኛለን? end behavior ወይም ደግሞ the end points of the graph polynomial function determined by the leading term that is n times x the power of n። ስለዚህ ለምሳሌ ይሄ ሊዲንግ ተርም ወይም ደግሞ የሊዲንግ ተርም ወይም ደግሞ የፋንክሽናችን ዲግሪው ኤን ኢቭን ከሆነ ሁለቱም ጫፎቹ በአንድ አቅጣጫ ወደ ላይ ወይም ደግሞ ወደ ታች ነው የሚወጡት ዲፔንዲንግ ኦን ዘ ሳይን ኦፍ ዘ ሊዲንግ ኮኤፊሽንቱ ፖዚቲቭ ከሆነ ሁለቱም ጫፎች ወደ ላይ ይወጣሉ። ሊዲንግ ኮኤፊሽንቱ ኔጌቲቭ ከሆነ ደግሞ ወደ ታች ናቸው ማለት ነው። ነገር ግን ይሄ ዲግሪው ኤን ኦድ በሚሆንበት ጊዜ አንድ ወደ ላይ አንድ ወደ ታች ነው የሚወጣው። ስለዚህ የትኛው በግራ ያለው ወይስ በቀኝ በኩል ያለው ነው ወደ ላይ የሚወጣ ወይም ደግሞ ወደ ታች የሚወጣ የሚለውን it depends on the leading coefficient that's simply n። ኦኬ ከዛ መልቲፕሊሲቲውን በምንመለከትበት ጊዜ if the given polynomial function has roots with multiplicity, that is if the multiplicity that's simply k, if k is even multiplicity so that the graph will bounces at the root ሩቱ ላይ ይነጥሩና ሳይቆርጠው ተመልሶ ወደ ነበረበት ከላይ የመጣ ከሆነ ወደ ላይ ይመለሳል። ከታች ወደ ግራፍ ወይም ደግሞ ወደ ኤክስ አክሱ የሚመጣ ከሆነ ደግሞ ከነክቶት ወይም ደግሞ ሩቱን ኤክስ አክሱን ከነካ በኋላ ወደ ታች ይመለሳል ማለት ነው። ኦድ በሚሆንበት ጊዜ ደግሞ ክሮስ ያደርገዋል። ክሮስ አድርጎት ከታች መጥቶ ክሮስ አድርጎት ወደ ላይ ይወጣል፣ ወይም ደግሞ ከላይ መጥቶ ከመጣም ደግሞ ክሮስ አድርጎት ወደ ታች ይወርዳል ማለት ነው። መቼ? when the multiplicity of the root of the given polynomial function that is k is 1 and it is odd, so that the graph will have this property. When it is odd and greater than or equal to that of 3, it flattens። ከታች ከቤዙ ላይ ከታች የሚምጣ ከላይ የሚምጣ ፍላት ይሆናል፣ ወይም ደግሞ it becomes very flat or simply wide. And the smoothness could be just the basic property of the graph of polynomial function. It is the smooth, that means the polynomial graph are continuous and smooth. That means the graph doesn't have any gap or any sharp point or simply any hole even, because it is a smooth or simply continuous curve. And the maximum turning point could be ቅድም እንዳልነው the maximum turning point could be a polynomial of degree n has at most n minus 1 turning points, and the maximum number of the x-intercept, or simply the roots of the given polynomial function, could be that a polynomial degree n has at most n number of x-interceptors. That means the number of x-interceptors is it could be identical with the number of the zeros of the given polynomial function. ስለዚህ the maximum number of x-intercept could be this one. ስለዚህ ነገር ግን አሁንም እዚህ ጋር ዲግሪው ኦድ ከሆነ የግድ አንድ x-intercept ይኖረዋል። ዲግሪው ኢቭን ከሆነ ግን the graph of the given polynomial function totally either above the horizontal axis or below the horizontal axis, so that the graph may not have an x-intercept, but it must have the y-intercept, which is obtained by letting x to be 0. So that these are the tips, or simply the main thing that should be taken into consideration when we try to draw the graph of a certain polynomial function. Therefore, based on this thing, the graph of the previous function could be, that is the graph of x cubed minus 4x squared minus 7x plus 10 could be look like this. ስለዚህ አሁን እዚህ ጋር ስንት ተርኒንግ ፖይንት አለው? የግራፍ የተሰጠን ፋንክሽናችን ዲግሪ 3 ነው። ስለዚህ 3 ከሆነ አትሞስት ኤን ማይነስ 1 3 ማይነስ 1 ሁለት ተርኒንግ ፖይንት አለው። አንደኛው ተርኒንግ ፖይንት እዚህ ጋር ነው። ሌላኛው እዚህ ጋር አለኝ። ሶስት ዜሮዎች አሉ። the roots are -2 I think +1 and +5። ስለዚህ እነዚህ ሶስት ፖይንቶች ላይ ግራፉ ኤክስ አክሱን ይቆርጣል ማለት ነው። ዲግሪው ኦድ ስለሆነ አንደኛው ወደ ላይ ነው የሚወጣው። ሊዲንግ ኮኤፊሺየንቱ ፖዚቲቭ ነው። ስለዚህ በዚህ በቀኝ በኩል ያለው ወደ ላይ ይጨምራል፣ በግራ በኩል ያለው ደግሞ ወደ ታች ይቀንሳል ማለት ነው። so that this is the graph of this cubic polynomial function. Okay, next a similar question. Find all rational roots of f of x equal to 6x cubed plus x squared minus 4x plus 1, and we are asked just to sketch the graph of the same cubic polynomial function. ስለዚህ መጀመሪያ ሩቶቹን እንፈልጋለን። ፋክተራይዜሽን በኢዝሊ ፋክተራይዜብል ስለሆነ f of x can be factorized r to x minus 1 through x minus 1 times x plus 2. ስለዚህ definitely from the linear factorization, the root of this cubic polynomial function could be this one, that is 1 over 2 from the first linear factor, 1 over 3 from the second one, and minus 1 from the third one. And next, the intercepts ግራፉን ለማግኘት ደግሞ እንደምናደርገው ኢንተርሰፕት ያስፈልገናል። ከዛ the intercepts could be ዜሮቹን እዚህ ጋር ካገኘው ኤክስ ኢንተርሰፕቶቹን ማገኘው ማለት ነው። ስለዚህ the x intercepts are 1 over 2 0, 1 over 3 0, minus 1 0, when 1 over 2, 1 over 3 and minus 1 are the zeros of the given polynomial function. ምክንያቱም የአንድ ፋንክሽን ግራፊካሊ የአንድ ፖሊኖሚያል ፋንክሽን ግራፍ የአንድ ፖሊኖሚያል ፋንክሽን ዜሮ ማለት የፖሊኖሚያል ፋንክሽኑ ግራፍ ኤክስ አክሱን የሚቆርጥበት ፖይንት ማለት ነው። ስለዚህ እነዚህ ኤክስ ኢንተርሰፕቶቹ ማለት እንደሱ ናቸው። ስለዚህ ዜሮቹ እነዚህ ከሆኑ የዚህ ፖሊኖሚያል ፋንክሽን ኤክስ አክሱን 3 ጊዜ ይቆርጠዋል ማለት ነው። and the points are 1 over 2, 1 over 3 0, and minus 1 0. And the x-intercept is every polynomial function has only one y-intercept, and this y-intercept will be obtained by letting x to be 0. So that is at the constant term. The constant term in this case is 1, so that 0, 1 will be the y-intercept. Then the graph of the given polynomial function could be ይህን ይመስላል። the graph of this polynomial function will be this one. ስለዚህ ምን ብለናል? አሁን እዚህ ጋር ዲግሪው አሁንም እዚህ ጋር 3 ነው። ስለዚህ አትሞስት ሁለት ተርኒንግ ፖይንቶች አሉት። ይሄው አለው እዚህ ጋር 3 ሩቶች ነበሩት። ሶስት ሩቶች አሉት። ስለዚህ 3 ኤክስ ኢንተርሰፕቶች አሉት -1 1 over 2 and 1 over 3 የተቀራረቡት ለዛ ነው። This is 1 over 3, and this one is, this is first one maybe 1 over 2, and no, 1 over 3 and 1 over 2, so that these are the x-intercepts, and this end tends to infinity in the upward direction without any bound. This will tend to negative infinity without any bound again. so that the graph looks like this. Okay, next, find the rational roots of this polynomial function and sketch the graph. ተመሳሳይ ጥያቄ ነው። መጀመሪያ ሩቶቹን እንፈልጋለን። the roots by using factorization. The roots are this one, that is 5 from the first linear factor, 1 over 2 from this, and minus 3 from this one. ስለዚህ የዚህም ፖሊኖሚያል ፋንክሽን ሩቶቹን አገኘ ማለት ግራፉን ለመስራት የሚያስፈልገን ኤክስ ኢንተርሰፕቶችን ማወቅን ማለት ነው። So that the x intercepts are 5 0, 1 over 2 0, and minus 3 0. The constant term is 15, so that it is y-intercept could be 0, 15. Therefore, if we put this information in the Cartesian coordinate system, the graph of the given polynomial function will look like this. It is, these are the x-intercepts. It has 2 turning points because the degree is 3. And its y-intercept could be this one. That is, it is just around 15 because it is 50. Therefore, the graph will have this property. Okay. Question number 17. Identify the holes, asymptotes, intercepts, and domain of f of x equal to 4 over x squared minus 3x minus 4, and then sketch the graph. አሁን ቅድም የፖሊኖሚያል ፋንክሽን ዜሮቹን እና ግራፉን ያየን። እዚህ ጋር ደግሞ ራሽናል ፋንክሽን ነው። ራሽናል ፋንክሽን ምን አለው? ሆሊን ሊኖሩት ይችላል፣ አሲምፕቶቶች ሊኖሩት ይችላሉ፣ ኢንተርሰፕቶቹ አሉት፣ ሊኖሩት ይችላል፣ ላይኖሩት ይችላሉ። ኢት ዲፔንድስ። ዶሜን አለው። ስለዚህ ይህን ካወቅን በኋላ ምን እናገኛለን? እንደገና ደግሞ ወይም ተጠይቀናል we are asked just to draft or simply just to sketch the graph of the given rational function. ስለዚህ ከምን እነሳለን? First, the domain is the set containing the whole set of real number without real number that can make the denominator to be 0. ስለዚህ x plus 1 x minus 4 እንደዚህ ፋክተር ስለሆኑ at minus 1 and minus 4 the denominator is 0, so that we should exclude minus 1 and positive 4 from being an element of the domain of this rational function. Okay. ስለዚህ አንዱ የፋንክሽናችን ግራፍ ስኬች ለማድረግ ወይም ደግሞ እዚህ ከተጠየቅነው አንዱ ጥያቄያችን ዶሜኑን አወቅን ማለት ነው። ሁለተኛው the vertical asymptote could be the vertical asymptotes are ይሄ ፋክቶራይዝ አልሆነም ከላይኛው ኦልሬዲ ኮንስታንት ስለሆነ ስለዚህ የታችኛው ዜሮቹ minus 1 እና 4 ከሆነ exactly x equal to 4 and x equal to minus 1 could be the vertical asymptotes for the graph of this rational function. Okay, then horizontal asymptote አለው። አንድ ፋንክሽን ራሽናል ፋንክሽን ሆሪዞንታል አሲምፕቶት የሚኖረው በሁለት ኬዝ ነው። አንደኛ የላይኛው ዲግሪ ከታችኛው በሚያንስበት ጊዜ ራሱ ኤክስ አክሲሱ ወይም ደግሞ y is equal to 0 ሆሪዞንታል አሲምፕቶት ይሆናል። በሁለተኛው ኬዝ ደግሞ የላይኛው ዲግሪ ከታችኛው እኩል በሚሆንበት ጊዜ the horizontal asymptote for the graph of the given rational function could be the line, the horizontal line. That means when y is equal to the quotient of the leading coefficients of the numerator and the denominator. ስለዚህ በዚህ መልኩ ይህንን በምንመለከትበት ጊዜ የላይኛው ዲግሪ 0 ነው፣ ታችኛው 2 ነው። ስለዚህ የላይኛው ዲግሪ ከታችኛው ስለሚያንስ y is equal to 0 ወይም ደግሞ x አክሱ ራሱ ለዚህ ራሽናል ፋንክሽን ሆሪዞንታል አሲምፕቶት ነው ማለት ነው። ይሄ ፋንክሽን ኦብሊክ አሲምፕቶት የለውም። ምክንያቱም ኦብሊክ አሲምፕቶት አንድ ራሽናል ፋንክሽን የሚኖረው መቼ ነው? የኑሜሬተሩ ዲግሪ ከታችኛው ከዲኖሚኔተሩ ዲግሪ በአንድ ሲበልጥ ነው። ስለዚህ ይሄ የላይኛው ከታችኛው ስለሚያንስ ኦብሊክ አሲምፕቶት አይኖረውም። ቨርቲካል አሲምፕቶት 2 አለው። ሆሪዞንታል አሲምፕቶት y is equal to 0 አለው፣ ወይም ደግሞ ኤክስ አክሱ ራሱ ሆሪዞንታል አሲምፕቶት ነው ማለት ነው። and the y-intercept could be the y-intercept is, that means the y-intercept could be when x equal to 0. I think it is an error. This is an error. The x-intercepts, oh, it doesn't have, I think, no x-intercepts, and Okay, yeah. Then it doesn't have any y-intercept. That's simply when the y-intercept means when y is equal to 0. 4 over x squared minus 3x is equal minus 4 doesn't have any 0. So that's this rational function or the graph of this rational function doesn't intersect the x-axis. ምክንያቱም ኦልሬዲ እዚህ ጋር x-axis ምንድን ነው ብለናል? ሆሪዞንታል አሲምፕቶት ነው። And the y-intercept could be when x equal to 0, it becomes 4 over minus 4, which is minus 1. So that 0 minus 1 will be the y-intercept. ስለዚህ የዚህ ፋንክሽን ዳፍ y-አክሲሱን 0 ኔጌቲቭ 1 ላይ ይቆርጠዋል ማለት ነው። ስለዚህ አሁን እዚህ ጋር ምን አገኘን? y-intercept ዶሜን አገኘን፣ ኢንተርሰፕቶቹን አወቅን፣ ኦብሊክ አሲምፕቶት የለውም። So that the graph would be ይህን ኢንፎርሜሽን ካርቴዥያን ኮርዲኔት ሲስተም ላይ ካስቀመጥን በኋላ if we see the property of the graph of the given rational function near the asymptotes, we can have the graph of the given rational function will looks like this. ስለዚህ the vertical asymptote y is equal to x equal to 1, minus 1, and this is x equal to 4. ስለዚህ ይሄ ግራፍ ይሄ ማለት when x approaches minus 1 from the left side, so that the functional value of the given function will tend to in the positive infinity. ምክንያቱም እዚህ ጋር ከዚህ ከማይነስ ወይም ደግሞ ማይነስ ኤክስ ከማይነስ ቱ በዚህ በግራ በኩል ወደ ማይነስ 1 በሚጠጋ ጊዜ ይህ ፋንክሽናል ቫልዩ ወይም ደግሞ ፋንክሽኑ 4 over x squared minus 3x minus 4 will tend to positive infinity, so that the graph will goes in the opposite direction, approaches from the left side. Similarly, when x go to that of negative infinity, when x go to negative infinity, ይሄ በጣም ትልቅ ኔጌቲቭ ትንሽ ኔጌቲቭ ነገር ግን በአብሶሉት ቫልዩ በጣም ትልቅ ቁጥር በሚሆንበት ጊዜ this one that simply ይሄ ላይኛው አይጨምርም አይቀንስም፣ ኮንስታንት ነው። ነገር ግን ታችኛው ኔጌቲቭም ቢሆን ይጨምራል በጣም። ስለዚህ a constant term divided by a very small negative number with very large in absolute value will tend to there, or simply will approach the x-axis or simply the horizontal asymptote of the graph of the rational function. በዚህ በኩል ባለው ወይም ደግሞ x equal to 4 የሚለው vertical asymptote ስንመጣ ራሱ ነው። That means when x approaches positive 4 from the left side, the graph will, or simply the functional value will tend to positive infinity, so that the graph will have this property. But when x goes to that of positive infinity, ይሄ በጣም ትልቅ ፖዚቲቭ ቁጥር በሚሆንበት ጊዜ x squared minus 3x minus 4 በጣም ትልቅ ፖዚቲቭ ቁጥር ይሆናል። ስለዚህ ይሄን ኮንስታንት ለዚህ ትልቅ ፖዚቲቭ ቁጥር በምናካፍልበት ጊዜ it approaches to 0, or it approaches the horizontal axis, that's simply the x-axis, from above, so that the graph will looks like this. ስለዚህ በእነዚህ በሁለቱ መካከል በሁለቱ ቨርቲካል አሲምፕቶቶች መካከል ያለውን ፕሮፐርቲ በምንመለከትበት ጊዜ እንደዚህ አይነት ከርቭ ይሆናል። y intercept that is simply 0 minus 1 is this one, so that the graph totally looks like this. Okay, next. Again, and that is similar question with similar rational function. ሆል ተጠይቀናል፣ አሲምፕቶት፣ ኢንተርሰፕት እና ዶሜን የተጠየቅነው እዚህ ጋርም። ከዛ መጨረሻ ላይ graph of the given rational function. The function is f of x equal to x squared minus 9 over x squared minus x minus 6. ይሄ ፋንክሽን አሁን ምኖች አሉት ከተባለ ያው ዶሜን ይኖረዋል፣ ዶሜን አለው። ፋክተራይዝ በምናደርግበት ጊዜ መጀመሪያ ፈርተር ሲምፕሊፋይ ብናደርግ we have this one, that is x squared minus 9 could be, the factorized form of the denominator could be x minus 3 times x plus 3, and the denominator could be ስንደምራቸው minus 1 እና ስናባዛቸው minus 6 የሚሰጠን minus 3 and minus 2, so that this could be x minus 3 times x plus 2. ስለዚህም further simplify ስናደርግ we can, this one that is simply x minus 3 ይሄ ጠፋና x plus 3 over x plus 2 ይሆናል. But this could be equivalent to that of this one when x is different from that of the ምክንያቱም ሁለት ፋንክሽኖች ኢኩቫለንት የሚሆኑት ተመሳሳይ ዶሜን ሲኖራቸውና ፋንክሽናል ቫልዩአቸውም እኩል ሲሆን ስለሆነ ስለዚህ እናገኛለን። ከዛ እዚህ ጋር x minus 3 እና x minus 3 ይሄ ጠፍቷል። ስለዚህ -3 must not be within the domain of this rational function። ስለዚህ -3 ላይ ምን ይኖረዋል? ይህ polynomial function whole ይኖረዋል ማለት ነው። so that the whole could be, if we substitute -3 here, I mean -3 for x, I mean positive 3 for x, 3 plus 3 is 6, 3 plus this one is 0, I mean 5, so that 3 6 over 5, 3 6 over 5, okay, 6 over 5 could be the whole. ይህ ፋንክሽን ሆል ይኖረዋል 3 6 5ኛ ነው። ይሄ ሆሉን ለማግኘት ኦሪጂናል ይህን ፋንክሽኑን አይደለም የምንወስደው። እዚህ ጋር ከወሰድን አንዲፋይንድ ነው የሚመጣው፣ ምክንያቱም ዲኖሚኔተር ዜሮ አት 3። ስለዚህ ሲምፕሊፋይድ ፎርሙም ይሄን ፋክተሮችን ካንስል ካደረግን በኋላ አፍተር ካንስሌሽን የምናገኘው ሲምፕሊፋይድ ፎርሙን ተጠቅመን የፋንክሽኑን ሆል የራሽናል ፋንክሽኑን ሆል እናገኛለን። ስለዚህ ሶልቭ ለማድረግ ሆል ያለው 3 ላይ ነው። 3ቱን እዚህ ጋር ሰብስቲቱት ስናደርግ 6 over 5 እናገኛለን። ስለዚህ 3 6 over 5 on the first quadrant, that means ይሄ polynomial function, I mean rational function ሆል ይኖረዋል ማለት ነው። ኦኬ ሌሎቹ ቨርቲካል አሲምፕቶት ስንል ደግሞ ቨርቲካል አሲምፕቶት ማለት vertical line which cannot be intersected by the graph of the given rational function ከዶሜኑ ኤክስክሉድ ያደረግናቸው ፖይንቶች ወይም ደግሞ ሴት ኦፍ ነምበርስ ካሉ ፕሮባብሊ ቨርቲካል አሲምፕቶት ሊኖር የሚችለው እነሱ ጋር ነው። ስለዚህ ኤክስ ኢኳል ቱ -2 is the only vertical asymptote for the given rational function። ሆሪዞንታል አሲምፕቶቱን በምንመለከትበት ጊዜ ደግሞ ምክንያቱም እዚህ ጋር የተሰጠን ፋንክሽን የላይኛው ዲግሪ እና የታችኛው ሁለቱ እኩል ናቸው። ስለዚህ እኩል ከሆነ ሆሪዞንታል አሲምፕቶት ይኖረዋል። ይህ ሆሪዞንታል አሲምፕቶት ደግሞ የሁለቱ የኒውሜሬተሩ እና የዲኖሚኔተሩ ፖሊኖሚያል ፋንክሽኖች ሊዲንግ ኮኤፊሽንት ይሆናል ማለት ነው። ስለዚህ ሁለቱም ተመሳሳይ ኮኤፊሽንት ነው ያላቸው፣ አይ ሚን ሊዲንግ ኮኤፊሽንት ነው ያላቸው and therefore y equal to 1 over 1, or simply y equal to 1 will be the horizontal asymptote for the graph of the given rational function። ኦብሊክ አሲምፕቶት አይኖረውም። ሌላው ኤክስ ኢንተርሰፕቱን በምንወስድበት ጊዜ ኤክስ ኢንተርሰፕቱ ማለት ቶታሊ የራሽናል ፋንክሽኑ ዜሮዎች ማለት ነው። የራሽናል ፋንክሽኑ ዜሮ ማለት ነው። የራሽናል ፋንክሽን ዜሮ ማለት ደግሞ ኒውሚኔተሩን ዜሮ የሚያደርግ ዲኖሚኔተሩን ግን የማያደርግ ማለት ነው። so that the zero of the numerator are positive 3 and positive 3 ነገር ግን positive 3, I mean positive 3 or -3 cannot make the denominator to be 0. ስለዚህ but 3 can make the denominator to be 0, so that 3 አይሆንም። ነገር ግን -3 could be the zero of this the rational function, so that 3 0 could be, I mean -3 0 could be the x-intercept of the given polynomial rational function። y-intercepቱን ለማግኘት xን ቶታሊ 0 ማድረግ ነው። 0 ስናደርግ ምንድነው የምናገኘው? ይሄ 0 ሲሆን we have -9 over -6 which can be further simplified to 3 over 2, so that 0 3 over 2 would be the y-intercept of the graph of the given rational function. ኦኬ ከዛ ዶሜኑ ምንድነው የሚሆነው? ታችኛው 0 ከሚያደርጉትን ኤክስክሉድ ስናደርግ ሴት ኦፍ ሪል ነምበር except -2 and positive 3 could be the domain of this rational function. And then the graph will be, if we put this information on the Cartesian coordinate system, we have the graph which looks like that of this one. A horizontal asymptote አለኝ and vertical asymptote አለኝ which is x equal to -2, and this is the y-intercept that is 0 or 3 over 2. They hit the x-intercept which is -3 0, so that the graph of the given rational function looks like this. You can observe the property. Okay, again similar question. Identify holes, asymptotes, intercepts, and domain of f of x equal to x squared plus 2x minus 3 over x squared minus 1, and then sketch the graph. ስለዚህ መጀመሪያ ሲምፕሊፋይ ማድረግ አለብን። ምክንያቱም ካንስል የሚደረጉ ተርሞች ካሉ እነሱ ማወቅ አለብን። ስለዚህ ዲኖሚኔተር ካን ቢ ፋክተራይዝድ አስ ኤክስ ፕላስ 3 ታይምስ ኤክስ ማይነስ 1 and the denominator is x minus 1 times x plus 1. ስለዚህ x minus 1, x minus 1. Therefore, the simplified form of the given rational function could be x plus 3 over x plus 1 when x is different from 1. Okay, ስለዚህ አሁን እዚህ ጋር ምን አለኝ? እዚህ at minus 1 ላይ ወይም ደግሞ at 1 when x equal to 1 ይሄ rational function vertical asymptote ሳይሆን ሆል ነው ያለው ማለት ነው። ስለዚህ the whole could be ይህን simplified ፎርሙን ነው የምንጠቀመው። አንድ ስንተካ እዚህ ጋር we have 1 plus 3 that is 4, 1 plus 1 is 2, 4 over 2 will be 2, so that 1 2 ላይ ሆል ይኖራል ማለት ነው rational function። ከዛ አሲምፕቶቶችን ስናይ x equal to minus 1 ብቻ ነው vertical asymptote የሚሆነው። ሆሪዞንታል አሲምፕቶቱን ስናይ አሁንም ይሄ ሆሪዞንታል አሲምፕቶት አለው፣ ምክንያቱም ዲግሪያቸው እኩል ነው። ስለዚህ የሊዲንግ ኮኤፊሽንቶች አንዳንድ ነው። so that y is equal to 1 is said to be the horizontal asymptote for the graph of the given rational function. ኦብሊክ አሲምፕቶት የለውም፣ ምክንያቱም የላይኛው ዲግሪ ከታችኛው በአንድ ስለማይበልጥ እኩል ስለሆኑ ኦብሊክ አሲምፕቶት የለውም። the intercepts could be the zeros of the rational function, that is minus 3, which is minus 3 0 could be the x-intercept, and the y-intercept could be just if we let y to be, I mean the x to be 0, 0 3 will be its y-intercept. So that the domain could be the set containing set of real number without minus 1 and 1. Then the graph will be this one. This is the vertical asymptote. This is the y-intercept. They hit the x-intercept, which is minus 3 0, and this one is 0 3, and this one is y is equal to 1, the horizontal asymptote. So that totally the graph of this rational function, which is x squared plus 2x minus 3 over x squared minus 1 will looks like this. Okay, the next question. Sketch the graph of f of x equal to x squared plus 11x plus 18 over 2x plus 1, showing all important features here. ፊቸሮችን እናያለን። አሁን እዚህ ጋር ምንድነው ከቅድሙ ለየት ይላል። ያው ግራፍ ነው ግን ከቅድሙ ይለያል። የቅድሞቹ እስካሁን ያየናቸው ምንድነው ቨርቲካል አሲምፕቶት እና ሆሪዞንታል አሲምፕቶት አላቸው፣ ኦብሊክ አሲምፕቶት የላቸው። ይሄኛው ኦብሊክ አሲምፕቶት አለው፣ ሆሪዞንታል አሲምፕቶት የለውም። ስለዚህ ኦብሊክ አሲምፕቶት ለምንድን ነው የሚኖረው? ምክንያቱም የላይኛው የዲኖሚኔተሩ ዲግሪ 2 ነው፣ የዲኖሚኔተሩ 1 ነው። ስለዚህ የላይኛው የታችኛውን ዲግሪ በአንድ ይበልጠዋል። so that the graph will have an oblique asymptote። ስለዚህ ኦብሊክ አሲምፕቶቱ እንዴት ይገኛል፣ አሲምፕቶቶቹን ኢንተርሰፕቶቹ እንዴት ይገኛል፣ ሌሎች አሲምፕቶቶቹ ሳሉት ወይ የሚለውን እናያለን ማለት ነው። ስለዚህ the denominator cannot be zero። ስለዚህ ይሄ ዲፋይን እንዲሆን ይሄ it must be non-zero, so that but the denominator to x plus 1 is 0 when x equal to negative 1 over 2. Therefore, the domain could be a set of real number without negative 1 over 2. They hit the domain. Because the domain is very important for the graph of the given rational function. ስለዚህ ይሄን ዶሜኑን በዚህ መልኩ ካገኘን ፕሮባብሊ ይሄ ቨርቲካል አሲምፕቶት ካለው x equal to negative 1 over 2 ነው ሊሆን የሚችለው። ስለዚህ አለው ወይስ የለው የሚለውን በምንድን ነው የምናውቀው? ሲምፕሊፋይ እናደርግና ፋክተራይዝ አድርገን ይሄ 2x plus 1 የሚጠፋ ከሆነ ሪሙቬብል ፋክተር ከሆነ ሆል ነው እንጂ ቨርቲካል አሲምፕቶት አይኖረው ማለት ነው። ስለዚህ after factorizing the numerator we have the factorized form of the numerator is this one. ስለዚህ 2x plus 1 ሊጠፋ የሚያጠፋው ፋክተር የለውም። therefore hence the polynomial function that is f of a can be expressed as x plus 2 times x plus 9 over 2x plus 1 over 2x plus 1. Then if I set the numerator equal to 0, that is x plus 2 plus and times x plus 9 is equal to 0, so that the zeros are minus 2 and minus 9. And thus the x intercepts could be ምክንያቱም የአንድ የራሽናል ፋንክሽን ዜሮች ማለት የራሽናል ፋንክሽኑ የግራፉ ኤክስ ኢንተርሰፕቶች ማለት ናቸው። ስለዚህ ማይነስ 2 0 እና ማይነስ 9 0 ላይ የዚህ ራሽናል ፋንክሽን ግራፍ ኤክስ አክሽን ይቆርጣል። ዋይ ኢንተርሰፕቱን ለማግኘት we need to set x to be 0። ስለዚህ x 0 ሲሆን ምን እናገኛለን? we have 18 because the function here is this is 0 times 0 plus 18 over 0 plus 1, that is 18 over 1, which is 18. Therefore 0 18 could be the y-intercept of the graph of the given function. This is the y-intercept. And the function could be the function that is x plus 2 plus times x plus 9 over 2x plus 1 has the vertical asymptote x equal to negative 1 over 2. It has an oblique asymptote. Oblique asymptote ለማግኘት ምንድነው የምናደርገው? using long division method ማካፈል ነው። አካፍለን ኮሸንቱ ማለት it must be linear polynomial function. That linear polynomial function could be used as an oblique asymptote for the graph of the given rational function. ስለዚህ ይህን ስናደርግ ምንድነው የምናደርገው? Since the degree of the denominator is 1 more than the degree of the denominator, it has an oblique asymptote. And this oblique asymptote will be obtained by performing or simply applying long division method. So when we divide x squared plus 11x plus 18 by the denominator, that is 2x plus 1, we have ለምሳሌ መጀመሪያው x squared የዚህ ሊዲንግ ተርም ለዚህኛው ስናካፍል ምናገኛለን? x over 2 እናገኛለን። ከዛ x over 2 በዚህ በዲኖሚኔተሩ 2x plus 1 አባዝተን የዚህ ፕሮዳክት ከዚህ ኳድራቲክ ተርም ላይ በምናቀንስበት ጊዜ we have this one, that is x squared minus this product will give us 21 x over 2 plus 18. ስለዚህ ይሄ እዚህ ስቴፕ ላይ ያገኘነው ሪሜንደር ነው ማለት ነው። ነገር ግን አሁንም ማካፈላችንን እንቀጥላለን፣ ምክንያቱም እዚህ ያገኘነው ሪሜንደር ዲግሪ አንድ ነው። ስለዚህ የምናካፍለውም ለዚህ ሊኒየር ስለሆነ we have to divide። ስለዚህ ለማካፈል ምንድነው የምናደርገው? የዚህን የአዲሱን ሪሜንደር ሊዲንግ ተርም 21 over x over 21x over 2 ለ2x እናካፍለዋለን። ስለዚህ ይህን ስናካፍል የምናገኛለን we have this one, that is 21 over 4። ከዛ 21 over 4ን ለዲኖሚኔተሩ በ2x plus 1 እናባዘዋለን። ስለዚህ ይህን ስናባዛ እናገኛለን። አሁን ይሄንን ከቅድሙ ሪሜንደር እንቀንሳለን ማለት ነው። that means 21x over 2 plus 18 minus 21x over 2 plus 21 over 4. ስለዚህ 21x over 2 21 over 2 ይሄ ይጠፋና 18 minus 21 over 4 could be exactly equal with 51 over 4. So that exactly 51 over 4 will be the remainder for which is obtained here. ስለዚህ ኮሸንቱ ምን ይሆናል ሲባል መጀመሪያ ላይ ምን አግኝተናል? x over 2 አግኝተናል። ከዛ እዚህ ጋር 21 over 4 አግኝተናል። therefore or then given polynomial function using polynomial division algorithm, f of x can be expressed as x over 2 plus 21 over 4 plus 51 over 4 over the denominator, that is 2x plus 1. ስለዚህ ይሄ polynomial function this linear polynomial function, that is simply this one, could be considered as an oblique asymptote for the given rational function. oblique asymptote ይሄ ኮሸንት ነው። ይሄኛው ሪሜንደር ነው። ይሄ ዲቫይደር ነው። ስለዚህ this is the linear equation or simply linear polynomial function which can be used as an oblique asymptote for the graph of the given rational function. Okay, and then the next one could be that is the oblique or slant asymptote could be okay እዚህ እንዳሳያችሁ ይሄ ነው የሚሆነው። ኦብሊክ አሲምፕቶት ይሄ ነው። ወደ ውስጥ ለገባ በደንብ አይታይም። y is equal to x over 2 plus 21 over 4 will be the y-intercept, I mean the oblique or simply the slant asymptote of the graph. Then then the function that is f of x given to be this one. then near the vertical አሲምፕቶቶቹ ምን ይመስላል ወይም ደግሞ ፕሮፐርቲው ምንድነው የሚመስለው የሚለውን ለማየት ኔር the vertical asymptote vertical asymptote እንግዲህ በዚህ ማለት x equal to negative 1 over 2 የፋንክሽኑ ግራፍ በቀኝና በግራ በኩል ምን ይመስላል? ለምሳሌ from the left side that means when x approaches negative 1 over 2 from the left side በዚህ በኩል በሚመጣ ጊዜ this one that is simply 2x plus 1 will approach to that of 0 and this 0 could be from the negative side so that ይሄ ምን ይሆናል ማለት ነው it tends with the negative ነው so that a constant divided by a very small negative number 2 which is closer to that of 0 from the left side is said to be a very small negative number with a very large in absolute value so that f of x will tend to negative infinity. ስለዚህ በግራ በኩል ይሄ x negative 1 over 2 በሚቀርብ ጊዜ ይሄ ምን ይሆናል ወደ 0 ይጠጋል from the negative part or ደግሞ from the left side. ስለዚህ ኮንስታንት በጣም ትንሽ ለሆነ ለዜሮ ቅርብ የሆነ ቁጥር ነገር ግን ለሆነ ኔጌቲቭ ቁጥር በምናካፍልበት ጊዜ የምናገኘው በጣም ትንሽ ኔጌቲቭ ወይም ደግሞ በአብሶሉት ቫልዩ በጣም ትልቅ ቁጥር ስለሆነ f of x will approaches to negative infinity to the left side of the vertical asymptote. በቀኝ በኩል from the right side when x approaches negative 1 over 2 from the right side f of x will tend to positive infinity. ምክንያቱም በዚህ በቀኝ ስንወስድ ከኔጌቲቭ 1 over 2 የሚበልጥ ቁጥር ላይ x በምንተካ ጊዜ ይሄ አሁንም ወደ 0 ነው ቴንድ የሚያደርገው ነገር ግን from the positive part ወይም ደግሞ from the positive side. ስለዚህ ኮንስታንት በጣም ትንሽ ለሆነ ለዜሮ ቅርብ የሆነ ትንሽ ፖዚቲቭ ቁጥር በምናካፍልበት ጊዜ we can obtain a very large positive number. So that in this case f of x will tend to negative infinity. Therefore the property of the graph of the given rational function near the vertical asymptote. Then the graph of the given rational function could be this one. The vertical asymptote is this one, which is x equal to x is equal to negative 1 over 2. They hit the oblique asymptote, which is y is equal to x over 2 plus 21 over 4. And they hit the y-intercept. That is, the y-intercept means x is equal to 0 ሲሆን 0 18. And the x-intercept could be ሁለት x-intercepቶች ናቸው ያሉት ብለናል። እነሱ ምንድናቸው? እዚህ ጋር the x-intercept could be the zeros of the given polynomial function. That means x equal to minus 9 and minus 2. So that the graph will look like this. The graph will look like this. Okay, that is all what I have for this video. Okay, አመሰግናለሁ። ያው ይህንን ቪዲዮ ላይክ ሼር እና ሰብስክራይብ ማድረግ አትርሱ። ለጓደኞቻችሁም ሼር ማድረግ ኮሜንት ማድረግ ብታደርጉም ደስ ይለኛል። አመሰግናለሁ።